Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So some time ago on Twitter, I noticed a very interesting, cool project which is called Quine Clock. Right, so essentially it's implemented by Matic Kleppe. I hope I pronounced their name correctly. So, and the idea is that you have this like a mess of JavaScript, right? So, and what it's capable of doing, it's actually capable of like printing itself on a page and acting like a clock, right? So there's a video in here that kind of demonstrates that. Also, I think there was somewhere a link where you can actually look at this entire thing. So here it is. So for people like in the chat, all of that it can be, received, achieved. So all of these links can be printed by the bot when you do today command. I forgot how to English today, okay. And for people on YouTube, it's going to be in the description. Right, so it's kind of cool. I don't really know how they achieved that because this thing is unreadable. So, and I don't know if it's like a legit Quine, right, that actually sort of like prints out its own source code, or maybe they're actually inspecting DOM and extracting this kind of stuff. Like, I don't really know. But this got me, gave me an idea that I could try to implement this kind of thing in C for the ANSI terminal. Right, so ANSI terminal, it actually allows you to have animations like that if you like, update the cursor correctly, right, and refresh the sort of like the scene that you rendered, and you can also have colors. You can kind of replicate this entire thing in the ANSI terminal, and on top of that, you can implement it as a Quine. So I don't know if I already said that. Like, what is a Quine? Quine is a program that actually prints its own source code, right? So if you never heard about it, and we had quite a few people in the chat in the press stream that don't know what is Quine. A Quine is a program that prints its own source code, right? So if you Google that Quine, it's actually a very interesting concept in the languages that allow you to inspect their own source code. It is actually pretty easy and pretty straightforward. Like for example, in Python or in JavaScript again. But I don't know if this one actually like uses self-referencing. So, but in the languages like C or Java, where you can't really read your own source code, it's kind of more difficult, right? So you have to actually use some interesting tricks. And if you try to implement Quine in a very naive way, you will notice that, right, so you have a program, and then you have a string that is supposed to print itself, but then within that string you need to have that string again, which also supposed to have that string again, and you kind of go into this infinite loop and you don't really know how exactly to print your own source code. So this is kind of like the trick in Quines, like how do you even do that? And I actually implemented Quines in the past, so I kind of know the idea of how it all goes. And yeah, I just want to try to replicate this cool and fascinating project. I don't really know if I'll be able to do that, honestly, right? So, but I kind of have like a roadmap in my head, right? So, and I want to try to attempt, doing that. I'm not sure if I'll be able to even finish this entire thing within the stream, right? So maybe I'm gonna do like a footnote and a flying footnote to finish this entire thing. We'll see. Like, I haven't decided yet. Right, but yeah, let's go ahead and try to do that. So the first thing I want to do, I want to kind of refresh how to implement Quines, right? Let's just implement a classical Quine, right, without any clocks or anything like that in C, just a program that prints its own source code. And once we have that, so the next step is going to be, let's implement just a clock without being a Quine. Right, so let's actually split the problem into two parts, right? Let's implement Quine and then implement like an ANSI terminal clock. And then we can see how we can combine these things together, right? So that's the roadmap I have, right? I kind of understand how to implement these two things separately. And I hope once I implement those two things, it's going to be more or less obvious how to combine them together. Know what I'm talking about? Right. So that's going to be basically the idea. Okay, so let's go ahead and do that. So I'm going to just create a file, quine.c. Right. So I'm going to just write a simple hello world, like so. Right. And just set up my building thing. set up my project, so to speak. So we're going to print hello world. So what I'm going to be using for building, I think I'm going to be using Knob, right? So because I'm probably going to have several programs here, right? And some programs I'm going to be running, you know, other programs and maybe processing some files. We'll see how it will go. So I'm going to just bring Knob in here, right? So this is going to be visualizer. And where is my knob? Knob.h. I'm going to copy paste it in here, and I'm going to create knob.c. Okay, so I'm going to include knob, and I'm also going to enable implementations, right? So because by default, knob acts like a header, and this is not what we want in here. This is definitely not what we want. And then we're going to enable, you know, go rebuild yourself technology. So knob, go rebuild yourself technology. It requires the argument, but it allows the executable, the build executable, to rebuild itself when it's modified. So the next thing we're going to do, we're going to create a CMD object, right? So I'm going to be just appending some things in here. So I'm going to append the compiler, right? So then I want to enable a bunch of warnings, right? So because it's always nice to have some warnings in here. Then afterwards, I'm going to, I suppose, say that the output is going to be quine, right? Because we're building the quine.c, and the input is quine.c. So afterwards, we're going to say run this entire thing synchronously, right? So it's going to block until the command is finished, and it's going to return false in case of an error. And in that case, we're going to say that we return non-zero exit code. Okay, so everything is prepared. So let's actually build this entire thing. Like so, and it cannot find knob.h, right? Let's try to do it like that. So this thing doesn't have to be by a pointer. There we go. So we build the build system. Now if I try to run the build system, it builds the quine. There we go. If I try to run the quine afterwards, the quine prints hello world, right? So that's basically what we have in here. So we have a prepared project. Okay, so what if you try to do a very naive thing, right? So, okay, the program must print itself. Okay, let's just copy paste the entire program and just say, okay, print yourself. Like, is it going to even work? Okay, so there's some problems in here with maybe new lines. We can try to replace new lines and stuff like that. So let's quickly replace new lines with like escapes and everything. There we go. Okay, so, and we also need to escape the quotes in here, right? So that should work as well. And if we try to run this entire thing, okay, so it kind of prints, but it doesn't print itself. It's not the source code, right? So as you modify this this thing, you kind of realize that like it doesn't print this thing anymore. So you have to kind of go recursively, and now in hello you have to copy paste it again. But now again, it's not the same program, so we have to keep copy pasting it indefinitely. And how you break out of that recursion? Like how exactly do you break out of that recursion and print your own source code? So it's kind of bizarre. But I mean, again, in C you can kind of like just maybe do something like you can include knob, right? So you can include knob.h. Knob read the entire file. You can basically read entire like file in here. And as far as I know, in knob, read entire file. Yeah, it's a write entire file. I need to read entire file. So to read an entire file, what you have to do is to have a string builder, because that's where it actually stores whatever it read, like so. And you can always do something like that, right? So, and if it's like not working, we're gonna just return 1. So, and in this specific case, we can just do fwrite. And how fwrite works, I can never remember the order of the parameters of this goddamn fucking function, mate. Goddamn fucking function. Right, so this is the pointer. So we have to say that this is gonna be SB items, right? So the size is going to be SB count. The amount of such things is going to be 1, and we're going to be printing all of that to the standard output. So that's about it. So we can now try to do this kind of thing. Yeah, so we need to also have the knob implementation. knob implement. There we go. So that is Quine basically, but among the Quine enthusiasts, it is considered cheating. Right, it is considered cheating to actually refer to your own source code. And furthermore, if you rename the source code, that exact executable does not print its own source code anymore. It's not even printing your own source code. It's literally just reading shit from a file and printing a file. It's not a Quine, honestly. It is not a Quine. So ideally, you want your Quine to be like a self-contained executable. You really want it to be a self-contained executable. So the idea of a Quine that I usually implement, so as far as I know, you can implement them in different ways, right? So you can be very creative in how you implement all of that. But the idea I use is an idea of an interpreter, right? So essentially, I'm sort of thinking about this entire stuff as a mini interpreted language, right? So, and I kind of embed the source code that I'm going to be interpreting into the program itself, right? So let's actually call it SRC. So, and what commands does this language have? What commands does it language has? It has command of a character, right? So if it encounters some sort of a character like A, it prints that character A. That's what it does. And to be fair, any character that it encounters, which is like a valid character in C, it will just print that character. There is, however, a special character, and I don't know which one to use, but I prefer to use like a question mark, maybe, because I'm not going to be using question marks throughout the program. So if that interpreter encounters a question mark, what it does, it just takes the entirety of SRC and prints that entirety of SRC. So that's basically the mini language that I implement within the Quine. Quine becomes an interpreter of that mini language, right? With a special command of question mark that just prints its own source code. So, and after that, after I just like denoted some sort of a source code in here, like it doesn't really matter, I don't have to write anything in here. Below, after that, I just write an interpreter for that language. I just write an interpreter for that language. So let's go ahead and write an interpreter for such language. So we're going to basically iterate throughout the source code, right? So, but we need to know the size of the source code. It's an ultimated string, so we have to do something like srcn, right? So we have to do strlen src, and I'm going to include string just in case. All right, so let's just iterate through the entire thing. Let's just iterate through the entire thing. All right, so srcn. So if you encounter question mark, right? So you just encountered a question mark. What you have to do, you have to print the entirety of the source code, right? Just print the entirety of the source code. So this is how we can do that, just src. If you encountered something else, we are going to print that thing effectively, right? So printf C. Maybe for now, it would be even better to not even use switch cases, right? Because I think it's just better to do something like this, right? If src equal to the question mark, just do that, just print the entirety of this entire thing. Otherwise do that. All right, though there is a couple of interesting things in here, right? I feel like it's like when we encounter like a backslashes, so we'll have to do something something different. Okay, so let's actually do it like that. So anyway, if I try to now run this entire thing and I sort of like print it, as you can see, it just prints the source code itself, right? So it encounters the question mark. The entirety of the source code is just a question mark, so it just prints this entire thing. So now what we need to do, we need to replace the entirety of the source code with itself, right? The entirety of the source code with itself. But we also need to replace the new lines and stuff like that. So let's actually go ahead and do that. So I'm going to query replace the new line. I already have that. Right, with like basically connect all of these things together like so. So, and now I'm going to just paste it in here. So there's a little bit of a problem, as you can see. So the double quotes, they also have to be escaped. All right, so let's actually do something like this. We're going to be escaping the double quotes. So now I can actually put it like that. Right, so and essentially, as you can see, the program below is going to be basically interpreting this entire thing and printing the characters as they are until it encounters the question mark. And then as it encounters the question mark, it will print the entirety of SRC and then continue printing the rest of these things, thus effectively replicating this entire program. So that's how you break this recursive loop. There is a little bit of a problem. Question mark now actually occurs twice. The second time question mark occurs is when in an interpreter I'm checking, is the current character question mark? So, and you don't really want to print the entirety of the source code in that specific case. So to sort of like circumvent that, you actually should not use question mark to check whether the current command is a question mark. So this is a very interesting thing. So what can you do in here? You can replace it with an ASCII code, right? So let me actually see. So what's the ASCII code of the question mark? So it's actually 63, I think. Yeah, it is 63. So let's go ahead and do that, right? So this is going to be now 63. And in here, in that specific question mark as well, you can replace it with 63. So now, as you can see, question mark is actually occurs only once. So not unfortunately, not 69. 69 is actually E. It's kind of funny how, you know, so the most meme letter also has the most meme ASCII code. Did you notice that? It's kind of funny. E. All right. So yeah, so that's basically the idea that I personally use for Quines. It's not finished yet, by the way. It's not finished yet, so it's not going to print precisely its own source code. You kind of have to like work on it a little bit. You have to handle a little bit more of these things in here, but we'll see. Okay, so yeah, there we go. So that's very interesting, right? So that's very interesting. It's actually kind of close, isn't it? Right, it's actually kind of close. So so the thing you need to do now, when you're printing your own source code, you actually have to escape it as you print. So here is the original thing, and here is the source code. Here is the sort of like inner source code, right? So we're already kind of getting closer in here. Okay, so as we print the source code, instead of blindly printing it, I suppose what we can do in here, we can actually, you know, print it also character by character, but then escaping the special characters and stuff like that, specifically new lines and the quotes, right? So that's what we can do in here. Right, so let's go ahead and do that. So srcn ++j, and now what I'm going to be doing, so I'm going to say if maybe here I want to actually do switch case, right? So it's going to be srcj. If I encounter a new line, right? So if I encounter a new line, this have to be case. I basically print, print like escape new line, right? So I use like a double backslash. So here I probably have to put a break. If I encounter quote, right, I have to print escaped quote. But here I have to actually escape it like that. There's so much escaping going on, it's kind of insane. And in case of a default, I just print that original character in here that we got in here. So that's basically the thing we can do in here. And I think that's about it. But if I try to run this entire thing, it kind of worked, but not really. Not really. Oh, I don't know what the fuck happened. Why did they put ++ in here? Right, so it's not the same code, actually. It's not the same code because, as you can see, the interpreter is not updated. So we need to now go back and sort of recompile this inner blob that we're interpreting, right? So we kind of have to recompile it. So we're going to put a question mark in here. We're going to take this entire thing, right? So I'm going to actually do something like that. Right, so what I need to do is query replace new line with /n, right? And also query replace this thing with this thing, right? So I need to escape all of that stuff. And that should enable me to put this thing back. So there's something, oof. All right, so there is also, yeah, this kind of thing. When I have, so I have to, yeah, probably this is what I have to do, I guess. Honestly, it would be actually maybe easier to just use ASCII codes for these things as well. Right, so I think it would be easier to use ASCII codes here too. Just a second. So, okay, let's actually see. New line, so let's put 10 in here. Let's put 10, and where is the quote? It's 34, so something like 34. But is it going to actually really help? It doesn't really matter actually that much. So we have to kind of approach escaping this entire stuff differently. So I think first thing we have to do, okay, so I think I've got an idea how exactly we're going to actually approach this entire thing. The first thing we're going to do, we're going to query replace backslash with double backslash, right? Because, yeah, if we start adding escapes for new lines and quotes, they will introduce their own backslash, which makes it impossible to do something like this. Right, this is understandable. Okay, so now I want to query replace new lines with /n, like so, and I'm going to query replace these things with double quotes, like so. So that's kind of the new blob, I think. That's kind of a new blob, and let's see if it's going to actually work now. All right, so I think I forgot a semicolon in here, so let me find this entire thing. So this is where we have to have a semicolon. Okay, so if I try to run this entire thing, and I think, yeah, there we go, it reproduced the blob. So one of the things we can do now, actually, we can try to run it into quine2.c. Right, so, and then we can simply compare quine.c with the quine2.c, and they are apparently not the same. So there's a little bit of a difference and discrepancy between them, and I don't quite understand. I suppose that comes from, I think I know where it comes from. So we also need to handle specifically backslashes too, right? So that explains it. All right, so, and basically you go like iteratively sort of like building upon this small interpreter until you get a quine, like an actual quine. Right, so and then here we just like print it like that. So if we encounter that, we just print it like that. Hopefully that will now work. So let's actually now recompile that blob. Right, so let's go ahead and recompile that blob. So let me see, and okay, so query replace backslash with double backslash. Look at the amount of backslashes in here, like holy shit. All right, so and then new line with a /n, and then the double quote with a /double quote. All right, so hopefully that is going to work now. So that's a pretty big blob, but this is because we never try to optimize this quine, right? So I'm just implementing quine in a very naive way, right? In a very straightforward way. So if I try to optimize like the size of this entire thing, I'm pretty sure we can make it smaller. All right, so now let me try to run this entire thing, and hopefully if I take a look at the difference between them, they're the same. So they're literally the same. So we can even do SHA-256, so sum for these two things, and they have the same hash sum. So that's how we implement quine in C. Like at least one approach to implement quine without using any trickery or anything like that. I personally call this approach an interpreter approach, Because again, you have sort of like a mini language, right, where each character is a command, and then you down there you implement an interpreter of that language, right? And because of that, this is why I say that quines are kind of akin to self-hosted compilers, because it kind of becomes a self-hosted compiler for this mini Turing incomplete language, if you know what I mean. Right, so, and now you can start optimizing and like shrinking down this specific interpreter, right? Shrinking down this specific compiler, and because of that, that blob will become smaller and smaller, right? So that blob is pretty big because the interpreter itself is pretty big, right? So, but if you spend some time, you know, optimizing this entire thing, it may become actually shorter, hopefully. So, and okay, so we know how to implement a quine, but how do I turn that into a clock? So essentially, one of the things I can do, right, is instead of just an interpreter in here, that prints this entire thing, actually not instead, but along with the interpreter, I can modify the interpreter, not only print this entire thing, but print it constantly in a loop, right? It's just like, this is a single print, this is a single iteration of a program, but now let's print it constantly. And as we print it, format it like a square on the screen, right? And then on the next iteration, always move the cursor to the left top corner. So as you reprint, it actually refreshes it instead of spamming the terminal. Right. So the first modification that you can do to this specific interpreter is just print the source code continuously, so you can play it as an animation. Okay, cool. So afterwards, you probably within the interpreter can constantly poll the current time. So as far as I know, like I already know how to get the current time. I implemented that in Suwon. Suwon has a clock mode. It can basically act as a clock. So this is my current time, right? If you take a look at the clock, right? So this is my current time. It's midnight actually, right? So I'm doing that in the middle of the night. So we can take a little bit of a code from Suwon on how to get the current system time. So we can embed that into the interpreter as well. And as we print different characters and stuff like that, we can also color specific characters with ANSI escape codes. So there's an interesting trick that I would like to steal from the original tweet. So what they do, they actually store the digits in a 3x5 bitmap encoded within an integer, within the bits of integer, right? So, and basically the bitmaps are here. So here is the array of bitmaps. We can actually steal this array of bitmaps. We can basically use the same font, right? And as we print the characters of the program, we can identify whether that specific character, which we interpret as a pixel, right? So whether that pixel is currently on some of the bitmaps, we can just color it differently, right? We can basically color this entire thing differently. That's the idea I have. So, and the most difficult thing here would be probably like, how do we format it so it looks nice? I can just throw something that looks like whatever, but how do you format it so it's like even in nice like that? I think that's the most difficult part. That's the most difficult part. Remove spaces, right? So you have to spend a little bit of time of just like adjusting these things around and stuff like that. But the main idea is actually pretty straightforward, I think. The main idea is actually pretty straightforward. So yeah, interesting. Yes. So what I would like to do, actually, I would like to implement an ANSI terminal clock without it being a quine, right? Just to get an idea of like what exactly do you need to implement such thing. Right, so let's go ahead and maybe create like a clock.c, right? So I'm not sure if it's a good idea to call it clock.c because there's some headers that are called clock, but I mean it's called they're called clock.h, not .c. So I don't think you're gonna create any particular collisions, name collisions or anything like that. So think it's totally fine. It's totally fine. There's nothing to worry about. Anyways, so let me put this entire stuff to here. I might as well actually factor out this entire stuff to something like build xz. So let's say that this function is going to return Boolean in case of some sort of an error. So here we're going to accept the command stuff, right? And here maybe we're going to accept the out path and in path, right? So what's called output path and const char input path. I don't really know why I do that in that specific order. Maybe this is because I do that in that order in here. But it doesn't really matter that much. So what we have to do in here, we have to replace this stuff with just this stuff, like so, but then we have to put something like this in here. So this is the output path and this is the input path, right? So as you can see here, since I'm using C, I can just like, you know, factor out a little bit of a code that is repeating itself. So, and in here, by the way, we can just simply return the result of you know, run sync command, like so. So afterwards, we can replace this entire thing with something like, you know, build xz cmd. So we need to have this kind of thing. We're going to pass it by a pointer. Quine.c. like this, and obviously it can return false in case of returning false, so we're going to return false here, not really false but 1, no zero exit code. So and now I can actually duplicate that, so now it is clock. There we go. So if I need to build another executable, I can just like, you know, add another line in here, right? So and I have a centralized place where I can update my flags and stuff like that. So all right, so this is knob, and let's see what we have in here. So it doesn't like something about first define. What the hell are you talking about, brother? Clock.c. Did I do a fucky wacky? What? What? Am I going crazy already? So clock.c. All right. Is that? Oh, CMD is a pen. Yeah, I keep forgetting about that. Get fucking damn it, I'm sorry. Right, so that's a very nasty gotcha. Okay, so that seems to be fine. That's cool. Thank you so much, everyone. Thank you so much. CMD's nuts. CMD's nuts indeed. All right, so now what we want to do in here, maybe we're gonna actually steal that bitmap thingy. Right, let me try to maybe just take this entire thing. So this is gonna be clock.c. And this is basically font, right? So we can maybe even say it's something like this, right? So this is the font now. We stole this entire thing. So one of the things I would like to do maybe is to inspect this font, right? Because it's rather fascinating, isn't it? Like, let's actually create a function that will print a specific character, right? So print font character. And we're going to accept just like this integer, right? So this is integer thingy. Let's try to interpret this 3x5 bitmap. 3x5 bitmap. To be fair, like in which order is it actually interpreted? So let me take this thing and open it like in Python. I'm going to take this stuff and I'm going to convert it to bin. All right, so they are interpreted starting from the most significant ones. That's fascinating, actually. So they're interpreted starting from that. Okay, that's very cool. So, and obviously I want to actually do print font char. Let's do font 0. Let's actually take a look at the first one. Yeah, so we know that there is like a 5 rows in here, right? So we're gonna start maybe with you know, y5, right? So there's a 5 rows, and we wanna start from, I mean, it's not that hard to do, I think, right? So we can then iterate these kind of things. So it's gonna be 3. Yeah, it shouldn't be that hard, honestly, because you can just do ch and you shift to the right right, you shift to the right. So if you want to take the first one, you shift y times, but it's actually y rows minus y plus 1, sort of speak. I think, or maybe even minus 1. All right, because if this is 0, I actually want to shift this entire thing 4 times, right? So, and that's exactly what's going to happen. So I suppose I need to define things like font rows, which is going to be 5, and font columns, which is going to be 3. So that means I can put stuff font rows and font columns, like so. Okay, so this is a font rows. And actually I want to shift not by this amount of things, but the amount of columns, right? So that means I have to multiply this entire thing by amount of columns, right? So that's the first shift that I have to perform. So, and after that I have to perform like another shift within the row that I have. And what's funny is that, yeah, once I got this one, I kind of have to do a similar trick. Right, so I'm shifting to the right with font columns minus x minus 1. Right, so funnily enough, I mean, we can actually combine these two things together like this, right? So, and that's basically what we have in here. So, and if that specific bit is true, that means it's highlighted, right? And if it's false, it's not highlighted. So we can actually print something like this in here. Otherwise, we can print something like dot, and at the end of the row, we just print a new line. So that's how I would attempt to decode that. It's a pretty verbose way to decode all of that. Maybe, I don't know, maybe it would be better to actually iterate it from a different order so you don't have to do these kind of nasty tricks, but we'll see. So let's actually take a look at the first thing in here, at the first sort of character, and see if it actually works. So there you go. So here's the 0. To be fair, instead of using dot, I would use space in here, so it will make it a little bit more readable, I think. So this is 0. This is what we get. Okay, so now I would like to maybe even include something like a knob, because I want to have like an array size. But to be fair, how many things do I have in here? So can I just do, so 11 words. Okay, so I can say that this is 10. Like we know, you know, for a fact that this is 10 because we have 10 digits. Maybe we can do something like digits count, and it's going to be 10. So, and we can just reuse this entire thing. So this is a digits count. So in here, I can just do something like size, digits count plus I, and then I just print each individual digit. Maybe it would make sense to have an extra new line to separate between the digits. And do we get some? Yeah, there we go. So here are the digits. So 0. Oh, they are reversed. That's actually very interesting. So they are kind of in a reversed order. So, all right, so let's actually fix that. I suppose let's not reverse them. So let's just use X here instead. All right. Okay, so now they are in a correct order. I'm really glad that I decided to like implement this sort of like a printer of the fonts. So now we know how properly decode all of these things. So exceed the indices of the array. Really? So did we exceed them? There's 11 of them. Wait a freaking second. All right. So what if I put, yeah, let's call it not digits count, but more like a fonts count. Font count. All right. So in here we're gonna say it's gonna be 11. So it's a colon. Another one is a yeah. Okay. So it's a colon, and it has an index 10. Essentially, right? Even though it overflows a little bit, but yeah, it's pretty cool. We just implemented the parser of the font, right? So that's very nice. That is very nice. Now we can basically try to maybe query the current system time. How do you even query the current system time? So we need to take a look at how Suwun does that. So let's take a look at Suwun. So main.c. So there's a subcommand called clock, and if it is enabled, we switch to the mod clock. All right, so in the mod clock, okay, that's how we do that. That's pretty interesting. So we get the local time, and the local time gives us seconds, minutes, and hours. That's actually too fucking easy, honestly. The fuck? Okay, so you get the time, and then you do local time, and that's basically the thing you have. Okay, so alright. Okay, so let me maybe remove that. So, and then I can just print all of these things. So let's say D, D, D. And in here we can say, so the first comes the hour, right? So this is the hour, this is the minute, and this is the seconds, I mean. All right, so let me actually see what we have, and all of that doesn't work because we probably have to include some scheiße. Probably have to include at least time, right? So I'm pretty sure about that. We have to include the time. Okay, oh, there we go. So that finally we have time. So it's 24:42, and if we take a look at the current time, 24:45, right? It's already moved on. Okay, that's pretty cool. We can even do something like 02, so we can pad all of these things with zeros, and there we go. So this is the actual time that we have in the system. So now we can try to maybe render it with the font that we have, right? So we can try to render it with the font that we have. So that will be kind of interesting. But the question is, so I suppose the amount of things, the amount of, we need to print it like, we need to print it character by character. So because we're kind of scanning from top to bottom and left to right. So as we know that the entirety, the width of the entirety of the clock, right? So the width of the clock is kind of like columns count, right? Is it called columns count? I forgot. Font columns, right? So it's a font columns multiplied by, so 2, 2, 2, 6 plus 2. 6 is the amount of digits in the clock, right? So two digits for hour, 2 digits for minutes, 2 digits for seconds, 6, right? Plus 2 digits for colons, for 2 colons, right? So it's basically plus 2. So yeah, so it's a 6 plus 2. So that's the entirety of the width of this entire thing. And the height is font rows. That's what we basically have. So we take the time, and what we can do now, we can just like scan, you know, top to bottom, left to right, right? And on each pixel, we can quite easily determine what digit it belongs to, so to speak, if you know what I'm talking about, like what exact digit it belongs to. I think we can do that. All right, anyway, so maybe it would make sense to actually keep it as int in here. All right, so let's keep it as int. And let's go ahead and maybe iterate this entire thing. So I'm going to start iterating it like so. I'm iterating height, and then I'm iterating the width as well. So yeah. So we're going to be determining the actual digits, the actual sort of slot, right, we belong to through X. So what we can do, right, so is just do maybe divided by font columns, right? So let me actually maybe draw what I mean in here, right? Because it's kind of difficult to explain it with just words, right? You need to kind of show it. Right. So essentially, you have the first digits for hour, then you have the second digit for hour, then you have a digit for column, and so on and so forth, right? And so on and so forth. They have a fixed width, right? A fixed width. So now imagine you just like iterating all of the pixels from left to right and top to bottom. And then you're currently working with this pixel. How quickly can you determine like what slot this pixel belongs to? You can take its x and divide it by the size, like by the size of this single thing. So what's going to be that size? Maybe I don't want to call it width. Let's call it s, right? So you divide it by s and you actually do the integer division. And effectively you get the index, right? You get the index of that slot, right? So this is 0 slot, 1, 2, 3, 4, and so on and so forth. So that, like, you render the pixel, you can quickly get the index of the slot you're currently in. Once you know the index of the slot, you kind of know what kind of slot it is, right? So you know that 0 is the most significant digit of our, 1 is the least significant digit of our, right? 3 is the colon. 3 is always the colon. Yeah, so 4 is the most significant digit of minutes, and so on and so forth, right? So through this formula, you can quickly identify the index, and through the index, you can quickly identify what kind of digit you need to actually print it. So that's basically my idea, right? So that I have in my head, but it's kind of difficult to explain with just words. You kind of need to show. You know what I'm talking about? You know what I'm talking about? I think you know what I'm talking about. Alrighty, so let's go ahead and try to do that. So, and the size, the width of this entire thing is basically font cones. What is a Quine clock? A Quine clock is an idea invented by Martin Klepper, and so this is basically how it looks like. Quine is a program that prints itself, right? This program not only prints itself, it also acts like a clock. So it's kind of an extension of a Quine idea, so which I find pretty cool. It's implemented in JavaScript, and I decided to take a challenge to implement it in C for the ANSI terminal. So that's basically what we're doing. So yeah. That's badass. That's actually pretty cool. That's actually pretty cool. I really like this idea. Right. Quine but clock but in C. Exactly. Okay. Shit looks hard. It is pretty hard, which makes it actually kind of cool. So it's actually a combination of like several tricks performed like sequentially in a chain. Right, so we already implemented a Quine, right? So I just refreshed how to implement Quines. Now I'm trying to implement a clock, and then I'll try to combine these two ideas together. And we'll see how it will go. We'll see how it will go. Okay, so I have this kind of thing. So this is the index. And depending on the index, how can I even approach this entire thing? So maybe I can actually pre-render all of, like, I can have an array of digits. That is actually kind of cool idea. I think it is a pretty cool idea. So let's call it digits, and this is going to be basically, I'm not sure if it's a good idea to call them digits, but whatever. So 6 plus 2, this is the digits that we have in here. So I get the current time. Okay, I get the current time. And now for digit 0, I can just get the hour, right, and I can basically divide it by 10, right? So I divide it by 10, and this is what I get in here, divided by 10. So yeah, that's about it. For this one, I actually have to do mod 10, right? So this is going to be the mod 10. So for 2, I'm going to be using just 10. Here's an interesting thing. I'm basically filling these digits with the indices within the font. That's what I'm doing. I'm filling it with indices within the font. So actually it makes it super easy to just repeat it like so. So this becomes more like 3, 4, 5. This is the minutes, and this is the minutes, and this is 10. And then, right, so this is going to be 6, 7, second, and second. So that makes it 8. So this makes it 8, which is exactly that, right? So the amount of digits here is actually 8. Honestly, I could actually just call it digit count. Digits count, which is going to be 8. So that means this becomes digits count. This becomes digits count. like so, and that's about it. So now I can do digits I, and I know exactly the digits I'm talking about, and then I can actually query even further and get the actual bitmap for that specific digit. So that's what I can do. It's actually pretty cool. Right, so once I've got this bitmap, I have to actually query its bits, right? So I need to determine whether that specific bit in there is filled in or not. And I can do that with this specific formula. Right, so I just plug, this is actually kind of insane, not gonna lie. Right, I can just use the same y, but the x has to be kind of different. X has to be within, like, from 0 to 3, right? So that means I have to kind of do a mod of the font columns or something like that. And effectively what I do in here, if this entire thing is true, I'm printing the star. Right, so I'm just printing this specific star, otherwise I'm printing nothing. So basically what I'm trying to do, I'm just trying to spell out the current time using the font. And I forgot the new line, which is fine, which is totally fine. So we can actually do it like that. So, all right, so that kind of worked, but they're stuck together, right? So they're a little bit stuck together. So because of that, I feel like the width of this entire thing has to be a little bit like digits padding, right? So let's actually introduce a notion of digits padding. Right, so define digits padding, and let's actually use 1 pixel for the digits padding. And when we're determining the index, we're going to be divided not by the font's columns, but plus digits padding, right? So that's what we're going to be doing. Interestingly, if x kind of overflows this entire thing, so we need to factor out this specific x. I don't really know how to call this x, but I'm going to call it maybe dx, right? So dx is actually mod of padding that is also included, but that means that dx may become bigger than the font columns, which will overflow the font, So that means, first of all, we need to also check that dx is less than font's column, something like this. So that's basically what I have in here. There we go. So we can actually maybe even use like a hash in here. So it's yeah, that's much better. Look at that. Look at that time. Look at that freaking time. Isn't it poggers? I think that's pretty freaking poggers. So what's cool about this code is that we are actually rendering that in one pass, right? And we don't use any intermediate like a memory or anything like that, right? It's not like we have an array into which we are rendering all of that first. No, we're just iterating each individual pixel once in one single pass, and we're rendering it as we go. Right, so that's what makes it even cooler. All right. So one thing we can do in here is that now we can even control the padding. So for example, if I don't like that the padding is 1, I can increase it, right? So I can make it a little bit bigger. To be fair, like a bigger padding looks much better, honestly. It actually kind of looks much better. So what's interesting is that we can use the same characters in here, right? And it will turn it into like a single blob. But now for a filled-in pixel, we can actually try to use the like ANSI terminal codes, right? But I don't remember the ANSI terminal codes and stuff like that. So let's actually go to ChatGPT. Right, so DuckDuckGo, by the way, has a built-in ChatGPT. If you guys didn't know, like I don't have an access to like an OpenAI ChatGPT, so that's why I'm using like a loophole and stuff like that. So let's use a dark theme. Print yellow text in C using ANSI terminal escape codes. Okay. Okay, so that's basically what I want. Thank you so much. Thank you, kind sir. All right. So, yeah. this is what we have, and now, yeah, essentially we can just do that. So I'm gonna assume that the last code basically disables, right, resets it back. Hopefully, I hope it didn't configure some bullshit. But the idea here is that hopefully it will print it with a different color. Yeah, okay, so the new line. So let's get rid of the new line. Now, yeah, there we go. So that's basically what I'm trying to do. So how to do red color? How to do red color? All right, so red color is this thing. So this is a red color. So it's basically 31. Okay, so I might as well just do something like this. So 33, and this is a 31. So because I think red color, yeah, red color is a little bit easier to read in here. Full block Unicode, maybe. Let's actually put a full block Unicode. Maybe it will look a little bit better. So this one, right? So let me quickly copy paste this entire thing, and yeah, not bad, not bad at all. So the next step is probably going to be basically playing it as an animation, if you know what I'm talking about, right? So we need to sort of continuously refresh this entire thing. So let me see. So yeah, we can just do an infinite loop like so. We probably don't need this kind of thing anymore. Right, so this is just an infinite loop. And on each step, so where I remember that I was doing the refreshing in the, how is it called? Game of Life, right? So let me see. Goal, I forgot. How was it called? So I just need, I could have asked ChatGPT, but I don't really know how exactly explain what I mean. It's just easier for me to grab that thing. So this is not articles. It's just easier to grab that thing that I was doing recently. Yeah, Game of Life. So, but I forgot how it was called. Was it called goal.c? I think it was called goal.c or something like goal. Or GitHub. Our goal trying to reverse Nick's goal. What was it called? What was it called? I forgot how it was called. And why is it not in the recent repos? Conveyed. Oh my god. Like, okay, so it was not called Go, it was called Convey. God freaking damn it. Alright. So Convey. The funniest part is that John Conway actually hated that he became known for Game of Life because he thinks that it's not the most impressive thing that he, you know, did. So it's kind of funny. I'm really sorry, John. But anyway, so this is the original one. And so what I need in here is just like escape codes that, yeah, go back. Yeah, so they just go back. They go to the left and up to the size of the sort of like a scene that they're rendering. So, and we're going to be doing that on each iteration in here. So this is going to be rows is H, and this is, you know, W. All of that is integers. We also need to sleep a little bit in here. So we're going to be doing you sleep. Man, you sleep. Man, you sleep. So this is, what does it use? Microseconds? I don't quite remember. So yeah, it is using microseconds. You sleep. So microsecond is actually 1/1,000,000th of a second. So this is going to be 1 second in here. So we can just use sleep in this case then, right? So since it's a clock, it needs to be updated only 1 second, once per second. Right, so let's actually take a look. Sleep. Yeah, no, this is a command. It's a command line command. Sleep 3. Yeah, this one. So let's actually do unistd. So this is a unistd. And let's put it in here. Okay, so I don't want to run it within Emacs because Emacs is a horrible terminal. It is a horrible terminal. Let's not do that. Right, so let's remove all of that stuff in here and let's go somewhere here. All right, so the clock. Now got a clock. We got an actual clock. Okay, so we got some subs. Thank you so much, Dr. Falcon, for gifting 5 community subs. Anshay, thank you so much for tier 1 with a message. GG, GG indeed. GG in fucking indeed, mate. So that's pretty cool. We got coin, we got clock. So the next step is to basically combine them together somehow. Right, so essentially what we can do, as we print characters, like we just print the full Unicode blocks. But what if instead of these full Unicode blocks, we would actually take the characters out of that SRC blob that we were interpreting? Right. So I think it's relatively straightforward to combine this thing with basically this thing. It's just like now we have to do the same thing on top of that. Right. So that's what we have to do. We just have to do this thing on top of that, if that makes any sense. So and the main difficulty here is going to be like, how do you format it nicely or something? How do you even format it nicely? Anyways, so yeah, but I'm already streaming for 1 hour and I'm a little bit tired, so I would like to make a little bit of a break. All right, so and you know, make a cup of tea. And after the break, we're gonna try to combine these two ideas together and see what we can do. Right. Okay, so how can we combine these two programs, right? So we have a Quine that is capable of printing itself. So here we just have an interpreter. And also we have a clock that actually, you know, shows the current time, which is kind of cool. So what I'm thinking is we are going to combine the loop that interprets this blob, this Quine blob, and the loop that renders a single frame of the clock. Right, so we're gonna combine them together somehow. Right, and we'll see how it goes. I actually want to maybe create even a separate, completely separate thing. So let's actually call it clock.c. Right, and in the build, I'm gonna just like add another line for an executable. So this is clock. All right, so in the clock, to be fair, I think I'm gonna just copy Quine in its entirety, like so. Right, and let's just rebuild this entire stuff and see how it goes. Okay, so that seems to be working. Now, for the clock, I think it also makes sense in the clock to remove print font char, because I don't think it's needed anymore, right? So it's kind of redundant. So if I rebuild this entire thing, so clock is still working. Okay, so let's actually start combining these things. So we need to add this stuff in here, right? So we already have stdio, we'll need time, uni std, and so on and so forth. So now we also have to have the font stuff. Let's bring it in here as well. So the font stuff. So to be fair, majority of this stuff probably will be inlined completely. To be fair, maybe the entire font in here. So we refer to font only once. So that means it can be quite easily inlined, like quite easily inlined. So I don't think it's that difficult to do. We'll see, we'll see. Also a lot of stuff. There's so much room for actually obfuscating this entire stuff. It's insane, honestly. It is honestly insane, but we'll see how it goes. Okay, so I think I want to kind of replace some of this stuff in here. I want to call this a display width and display height. Yeah, right, so this is going to be define display width, and this one is going to be display height, because that's what it is, right? So it's a single display height. So this is going to be font rows. Let's try to now rebuild this entire thing. So it complains, yeah, display height And the other thing is display width. And it seems to be compiling. Okay, so display height, display width. All right, so let me double check if the clock still works. Okay, so that seems to be working. That's pretty cool. So we have this entire stuff. I'm gonna maybe refresh it a little bit, like so. Okay. So now this is the single iteration. So I suppose we need to have this infinite loop that prints this whole thing over and over again. Right, so here is the single printing of the source code. As already said, we have to print it over and over again, which makes sense, sure. So the next thing, we're getting the time and we're preparing the digits. Getting the time and preparing the digits. That makes sense as well. So and afterwards, we're doing something interesting. We're just iterating each individual pixel of the display. So that's what we do, iterating each individual pixel of the display. But here we are iterating these things. So I feel like we need to maintain X and Y separately from this loop. Right, so here we're directly iterating the pixels, X and Y pixels. So that's what we're doing. We're just directly iterating them. But here, as we iterate characters of that blob that we're interpreting, we're going to be modifying X and Y. So essentially, if you encounter a new line as you try to interpret this entire stuff, we're going to be incrementing Y and resetting X to 0. So that's what I think we're going to be doing. That's what I think we're going to be doing. I think it's kind of cool, actually. All right. So initially, both of these things are going to be 0, right? So both of them are 0. Now, I feel like I kind of want to switch to switch case, right? So let's actually do this switch case. Right, so that means in here we have like a case 63, not even 69. Absolutely fucking disgusting, mate. Absolutely fucking disgusting. All right, so this is that, and this one is going to be just break. Okay, so in here we have the default, and this is just that. Cool, and then we close this entire stuff. So now the next thing, if we encounter a new line, I suppose what we're going to be doing, we're going to be incrementing Y, but also resetting X to 0. That's what we're going to be doing. Incrementing Y and resetting X to 0. If we're just printing something else, to be fair, yeah, so we also have to say that we're printing new line, right? Because that's not what it is. If we encounter something else, we're incrementing X. Right, we're just incrementing X. And when we're printing the entirety of the source code, we're always incrementing X. So that's what we're doing here. All right, and that honestly just gives us yeah, it just gives us the character. What I'm thinking, so here we just print this kind of stuff, so we print several of these characters. We need to be able to, at any point, and this one is actually very interesting. So since here we're printing several characters, right? We're printing several characters. Why 63? Because it's an ASCII code of question mark. And question mark, it's a special command that we're interpreting in our mini embedded language for the Kawaii. So yeah, that's what it is. It's an ASCII code. So this is not correct, by the way. This is not correct. Because here we're printing 2 characters. And here we're also printing 2 characters, and here we're also printing 2 characters. So effectively, we have to actually kind of update X sort of like 2 times, like every time we print the special characters. That's what we have to do in here. So if it's a special character of some sort, it's going to be x plus 2 rather than x plus 1, because again we're printing 2 characters in here instead of 1. And if we don't print a special character in here, we just do x plus 1. Now, like so. So that's basically what we're doing here. But interestingly, so can we even maybe split all of that into printing a single character, in a sense that we're gonna do x plus 1 twice. So this is the second character that we're trying to sort of print. And this is a little bit annoying, right? So I can split it like that, like so, and like so, and this is sort of the second thing. So this is what I want to do. I want to bring all of the printfs to the sort of form where they print only a single character. By the way, do we have a function that prints just a single character to the standard output, like putsi? Ootsie. So there is a put char. So this is probably what we're going to be using, like once I actually transform everything in here, we're going to be using print char. So I'm going to just grab this entire thing. I'm going to just put printf, another printf in here, like so. And then I'm going to duplicate this entire thing and boom. All right, so this is what I want to do in here. So as you can see now, we have printfs all over the place. Printfs all over the place. So I'm thinking, can I now query replace all of the printfs to put char? So query replace printf, put char. Boom, 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 boom. I want you in my room. Let's spend the night together in my room. So we got some subs with some messages. Thank you so much, Red Santar, for Twitch Prime the message. I finished yesterday your VOD about Essence OS. You say that at some point you would like to make your own OS. How would it be POSIX with GUI? Like your content, I like your content a lot. Thank you. So I'm thinking about non-POSIX but with GUI, right? So it's going to be Terry Davis arc, basically. So because POSIX is just like, I mean, it's kind of a, you know, it's boring. Like everyone knows POSIX. As I already said, I would like to have an opportunity to just experiment. What exactly is it going to be? I'm not quite sure. So I haven't decided yet, but it's definitely not going to be POSIX primary, so to speak. So maybe it's going to have like a POSIX compatibility layer, like in Essence OS, but the core is not going to be POSIX, right? Unix-like, probably not Unix-like, because like I want to experiment with some things. Like, what's the point of making your operating system if you're going to just recreate the same mess, software mess that we had for decades, actually for more than half of a century, right? So because I'm pretty sure Unix is like more than half of a century old. So what's the point of recreating that? So since we're doing recreational programming, it only makes sense to just make fun, to have fun, to make fun, to have fun. Right. So yeah, that's basically my idea. So thank you so much for the Twitch Prime. Okay, so here I need to go through all the put chars and I need to replace the double quotes with single quotes, but I'm pretty sure the compiler will just tell me all the places where I have to do that. Okay, so that's pretty cool. Right, so I can just do it like that. And the reason why I wanna actually update those things separately, because at any moment, right, in here, I wanna take X and Y and I want it to ask, should it be colored differently or not? Or maybe I can even factor out printing a character to a separate function. That sounds like a cool idea, honestly. That sounds like a cool idea. Just factor it out into a separate function where you make the decision. All right, so, okay. So a variable digit is not used. That's understandable. That's fully understandable. Okay, so I need some sort of a function. All right, I don't really know how to call this function. I'm going to call it foo. So what I'm thinking is that it's going to accept x and y, and maybe it's also going to accept the current time, right? So let's say that it's going to accept the tm thingy. And it's going to also accept the character that it wants to print, right? So it's going to be ch, so to speak. And this thing is going to render the pixel, right? So let's call it a render. Maybe we're going to call it pixel, right? So this is basically the pixel. It's going to contain this sort of logic, right? So we have x, and yeah, we have also, do we have y? I'm not really sure about that, but whatever. Okay, so let's copy paste this entire logic in here. So interestingly, yeah, so here's the character. So we're just printing this character like so. We're just printing this character, and we're just printing this character like so. What I want to do is also filter out situation when y is greater than the amount of rows, right? Because it's going to overflow basically. So essentially y has to be within font rows, and dx has to be within font columns, and then this thing has to be that. Otherwise, just print it as it is, right? So and that thing hopefully is going to just print the current character, the current pixel, with the corresponding color and the time and stuff like that. So we'll see how it goes. So it's not going to be formatted properly, but it's going to try to resemble the clock, right? So it's going to try to resemble the clock. Okay, let me try to do the following thing. So we have 9 of these things. So this is a pixel. Then we do x, y, tm. Right, for each of these things, we're doing that logic. We're combining all of that stuff together. So now I'm gonna. So we probably want to put the digits in here. Honestly, I think we should be accepting digits as a parameter in here instead of the tm. I think that makes more sense because that means I'm recomputing the digits every time, which is not particularly convenient. Right, so this is a digits count, and I'm gonna move that stuff somewhere here, right? So that's what we have in here. So let me find the pixels. So there's 9 of them. So this is digits. All right, that's pretty cool. So let's try to compile this entire thing and see. Okay, it compiled first try. Interesting. So now we need to kind of recompute the blob. That's what we need to do. So the main problem in here is that what is it going to do? Here's the thing. What is it going to do? It is going to literally print the entirety of the source code, and it's going to try to render a clock on top of the source code. And if there's not enough place to the right or to the bottom, it's gonna cut off the clock. So imagine clock rendered on top of the source code. So, but you're not gonna see anything to the right in here. So as you can see, there's not enough space in here. And also, this is a pretty huge source code, honestly. So what I'm thinking is that maybe I'm gonna kind of limit it a little bit, right? So let's say that I'm gonna only print if y is less than font rows, right? So for now, it's not going to print the entirety of this entire thing. It's going to just cut it out so we can at least see if it's working or not. Right, so that's basically the idea, if you know what I'm talking about. Okay, so let me try to do it like that. And now we need to recompile the blob, sort of speak. We need to recompile the blob. So let me take the temporary thing, and I'm gonna recopy paste this entire stuff. So I'm gonna query replace, and I'm gonna replace all of the backslashes in here, right? So backslash is double backslash now. To be fair, let's get rid of the comments. I think comments are not particularly great in here, so I think they're gonna be actually interfering with what I'm doing. let's recompile one more time just to make sure that I didn't make any mistakes. Query replace backslashes with double backslashes. Makes sense. Okay, so query replace now new lines with slash ends. Boom. So that's now the blob that we have in here. It's a pretty huge blob, not gonna lie. So, and let's query replace double quotes with slash backslash double quotes, like so. That's our blob. Okay, so that's a pretty huge blob. Yeah. But again, so this is a very first like naive implementation, right? So we'll just see how it goes. We'll just see how it goes. Okay, so I'm gonna try to recompile this entire thing. It seems to be compiling, so I can try to do clock now. Do I even have it? Clock. Okay, so there is a. I see what's going on. I see what's going on. Okay, so we are not resetting the view. So this is one of the things I forgot to do in here. We're not resetting the view. So after we rendered everything in here, I suppose what we have to do this thing. And we also have to sleep a little bit, but that's fine. All right. So, but I feel like what we have to do is, yeah, we have to use Y and X. So because we are updating X and Y as we go, so we don't really know upfront like how much we have to move, right? So we have to reuse these sort of things. All right, so I guess that makes sense. I guess that makes sense. Okay, so I'll try to recompile this entire thing and let's go. Okay, do you guys see that? Do you guys see that? So there is have like a little bit of a 0 and a little bit of a 1, and this is the spaces and stuff like that, right? And this is ours, that's why it doesn't really move. It's a 0, 1 colon, right? So you see what I'm talking about, right? So you see the direction I'm trying to move to. So the thing we need to do now effectively is to just like format it around a little bit so it like looks nice and everything. Like I don't freaking know. So, and we have to keep recompiling the, you know, the blob, right? And until we get something that sort of resembles this entire thing. I don't really know how it's gonna go, right? But I suppose these things are out of the window right away. But to be fair, I would like to first commit whatever we have, because by itself, it's already kind of a working idea, working example. It's just like now you need to reshape the code. So yeah, I have a pretty clear path. It's actually a pretty clear path. So all of the pieces kind of went together, and it's more like a you know tweaking around. So before I go into that, I think I want to do a commit, right? Because I don't want to lose the current work because it's already kind of working. So I'm gonna do git init. Right, let's initialize this entire thing, and I would like to git ignore some things in here. Right, let me see what I need to git ignore. I need to git ignore clock. To be fair, you know what? Let's actually remove all of these executables that we created, right? So let's remove all of them. In a knob, we're gonna create a build folder, knob.h make dir if not exists, right? So let's create the build folder. So this is the build folder. If not, right, return 1. And in here, we're gonna just say, okay, build that into that. All right. So if I try to now knob this entire stuff, right, it creates the separate folder. And as you can see, there's a nice build folder in here where it put all of the executables. All right. So now in git ignore, I can just say, okay, ignore build folder. That's it. I don't have to worry about that. So another thing that we probably have to ignore is knob and knob.old. All right, and that's about it. So quine2 is not really needed in here. So I'm ready to commit all of that stuff. Ready, set, go. All right, so now I'm not gonna lose any of the progress because I'm gonna be actually doing pretty destructive actions in here. The first action I would like to probably do. So let's get rid of this blob. I'm gonna recompile it a little bit later. So I want to try to get rid of these things. Right, so, you know, includes and stuff like that. I don't think they're particularly useful. So let's try to, yeah. Okay, so it doesn't know about printf, which is understandable. But it's just implicit. It doesn't really matter. So size t. Okay, so this could be just int. Doesn't matter. So let's try to recompile. Are there any errors? I'm specifically looking for the errors. Okay, time t. So let me try to do the following thing. So if I take a look at the time function, time t, what is a time t? Do we have the definition for the time t? I suppose time t is more like an integer. Right, it's more like an integer. Let me see. So is there, so I can probably do rg vim grep time t, and maybe it's a type def of some sort. Can I do something like that? Will it find that thing? Okay, so we almost found it. The time t, so this is snd sec. Ooh, which one is that though? Which one is that though? I don't really know. So maybe it's a time t. So all right. So but what is that thing then? What is that? It's not really well known, though we can try to actually search for that thing as well. Time t. All right. So okay, cool. So maybe I can just try to say, okay, it's an integer then. It's an integer. All right. So let's do nob. All right. So what kind of errors we have in here? Error. Null, it doesn't like null. Okay, let's say it's 0. Error. Okay, we need a definition of struct tm. Right, so maybe that's compiler defined. Yeah, probably it's compiler defined. Struct tm, I feel like we still need to include time. Right, so, but maybe we can include it somewhere down there. I'm freaking on. So, and now it compiles. So the problem here is that like we need to yeah, include that freaking time. One of the things we can do in here, we can also substitute font count everywhere it's needed. To be fair, it's not needed anywhere, so we can just put it in here like this. So we can just inline all of these, you know, things. We can just inline all of them. Let's go ahead and do that. So we replace that with 5. Boom. Cool. Remove that. We replace that with 3. Boom. Remove that. We replace that with 8. Boom. Cool. So digits count. Yeah, we just got rid of that. Digits padding. All right. We replace that with 2. Bam. So this one is interesting. So this is basically 5. It's 80, right? 5 times 8. Yeah, it's 80. I do remember that. Right. So it's 80. All right. So we replace that with 80. Actually, yeah, it's not even used that much. Honestly, that's pretty funny. And display height, is it used anywhere? We don't even use any of that shit. That's pretty surprising. So we can just remove all that stuff then. Okay, that's pretty cool. If I now just recompile this entire, it seems to be compiling. That's pretty cool. Yeah. So what do we do in here? What do we do in here? Can we simplify some of that stuff? Honestly, maybe we can actually compress a lot of this stuff in here. I think we can. I think we can compress quite a few stuff in here by simply doing case. Yeah, let's actually copy all of these things. That, and that. Right, so essentially if you encounter any of these things, we do that stuff, but afterwards, after you fall through, we do that. Okay, so that enables us to get rid of this entire thing. effectively. All right, that actually simplifies the whole interpreter quite nicely, as you can see. Is that cool? I think it's pretty cool. I think it's pretty cool. So yeah, that's actually, yeah, it's at some point I think it's gonna be pretty nice. So I'm thinking how are we gonna be approaching this thing, but it's not that big of a deal. All right, so let me try to compile this entire thing. Is it compiled so it doesn't like something? Oh, there's no errors in here. Yeah. So what's the error? The actual error, expected declaration. Okay, so I fucked up something. So what exactly did I fuck up? I see what I fuck up. All right, so that's fine. So there's no error in here anywhere. That's pretty cool. That's pretty cool. So I'm just thinking, what else do we need in here? So if it's a new line, you just do new line, blah 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 blah. Okay, so let's try to maybe do the following thing, like so. Yeah, something like this. A little bit of an obfuscation of our nation. All right, cool. So that's already kind of interesting, right? So you can already probably see something in here if you try hard enough. So yeah, that's already a pretty good canvas, if you ask me. So now let me compile the blob. Let me quickly compile the blob. So I'm gonna just put this blob in here, and I'm gonna query replace backslashes with, actually, yeah, backslashes with double backslashes. Boom. Query replace new lines with /ns. Query replace quotes with escaped quotes. Boom. So that's a blob. It's actually already a smaller blob, which I really like. Okay, that's pretty cool. All right. So let's try to compile this entire thing. All right, it seems to be compiling. Clock. So it's a build clock. Segmentation for holy fuck. All right, so okay, so that's pretty cool. That's pretty cool. Didn't expect that, honestly. That's the last thing I expected in here. I wonder what exactly. So it's probably something. That's professional C experience. Yeah, exactly. So what the fuck did I do? How did we end up like this? So it's gonna be x plus 1. That's one of these. Let's do a GDB. Node.c. So let's just add GDB, and let's recompile this entire thing. And I'm going to just do clock GDB. Let's just run it and let it at least see where exactly. Okay, so that's pretty cool. It's segfaulted at digits, which doesn't really make any freaking sense. So what's up with that? So, 14. Did I do fucky wucky? Oh, I actually updated the entirety of the source code. I need to recompile the blob again. Right, so I need to recompile the blob again. But to be fair, what if I just like use this thing? Right, I just use not compiled blob build clock. Right, is it gonna segfault? Yeah, it's still segfaults, which is perfect. Okay, one more time, just in case. GDB build knob clock run. Yeah, it's bizarre. Why is it segfaulting? Is that because it's not? Ooh, I think I might be knowing why. I think I know why. because integer might be of a different size than the time t. Oh yeah, local time fails. Yeah, that's probably why. So something about that. Yeah. Okay, that explains it. I think that explains it. So, all right. So that's pretty cool. So let me see. So you do need the this goddamn time definition. I really hate that you need that. It's kind of an ass, honestly. It's kind of an ass because it doesn't allow me to do this kind of shit, right? So I can't just do that. Or can I? Yeah, I can't do that. So where's the error? Initializer, yeah. So it's just like it requires you to be like that, which is absolutely annoying. Honestly, in all honesty, it's kind of annoying, but it is what it is, and it isn't what it isn't. So I don't think there is much we can do about it, except maybe completely moving this entire stuff somewhere like down there. Or you know what? Just move this thing up there and render one pixel down effectively, or just like render one pixel down. So that's about it. I think that's the easiest way to approach that. So on the rest of the stuff, you just like format it however you want. That makes sense to me. I think that makes sense to me. But for now, just to be able to see some stuff, I'm going to be actually putting that in here. Anyways, let's try to recompile the blob. So let's recompile the whole thing just to make sure that it's doing something right. But to be fair, like whatever I have already right now is already pretty good success. I didn't expect that I will be able to do that. Typedef underscore, like this is okay, but I also need the definition of struct tm. So it's not about even time t, it's also the definition of this thing. So you kind of need that, unfortunately. This is what it is. But anyway, it doesn't really matter. So where is the blob? Yeah, so here's the blob. And I'm gonna query replace this kind of stuff. Maybe I can just do it like that. Boom. Query replace the new line. Boom. Query replace the quotes. Boom. Oh, right. It's pretty beefy blob. I'm gonna put that stuff in here. Okay, so does it compile? Seems to be compiling. Alright, so now if I try to run... Fuck me! Alright, so, and... It was not that though. Alright, so let's do GDB. Let's try to run it. Okay, so now we kind of know where exactly it fails. So something about the digits I and everything. So can I just print I? So okay, that makes sense. Digits I. If I print digits I, it should probably give me... Okay, so I see what's going on. So digits... And when we actually printing... So that's bizarre. Maybe try long in. Why are you so fixated? Okay, it's just chat being chat. Like we had in the previous working version thing with time t. Like it's just like the only reason why you're suggesting that is because you wasn't watching carefully. It's absolutely not helpful. There we go. This is a working version. Whatever. So I made this kind of a weird mistake somewhere, and I don't really understand where. Like, probably I need to start over. Might as well actually put assert tm in here just to make sure that local time returned correctly. And for the assert, you need to have assert. Assert. Okay, so Let me see what's going on. No, it's not about that as well. Oh man, I don't want to start over, but it feels like I need to start over, but I don't want to start over. Fuck. I guess I have to start over. I guess I have to. Alright, let's start over. I really didn't want to. Fuck. Yeah. So this time I have to be a little bit more careful. Alright, so if I do that, it does this thing. So let's be a little more careful. So it's not really a failure, right? So we at least learned that we... Maybe it's super important to have some of the definitions in here. Let me try to do the following thing. Okay. So this is that, and if I try to... Nah, it's not about that. Okay, so we're gonna be doing all of that stuff like slowly and incrementally. Query 11, boom. So, and in here, yeah, whatever. I'm gonna just keep it as it is. So knob, let's just try to run it. Okay, seems to be working. Cool, cool, cool. So font rows query replace 5. All right. Query replace this with 3. All right. Query replace this with 8. All right. Replace this thing with 2. All right. 5. Double check that 5 multiplied by 8 is... Oh my... Python, work faster. Okay, so it's like my laptop is lagging a little bit. So I'm gonna just like double check. I just want to double check that it is the case. Alright, so this one is not used, whatever. Query replace that with that. Alright, whatever. So we got that. So that's pretty cool. Now, if I do that, this seems to be alright. Okay, everything's fine. Everything's Gucci, everything's Tamaguchi. That's pretty cool. So can I just like put together some of these things in here? Right. I think I should be able to. Alright, so let's put it like that. But one of the things, yeah, so this stuff compiles and it works. Okay, that's pretty cool. I have a feeling that maybe I fucked up something when I was merging these things. That's the feeling I have. Right. That's the feeling I have, but I'm not 100% sure. But whatever. So let's take the blob. Let's take the blob. So this is going to be question mark. Yeah, let's recompile the blob. So yeah, query replace that. This. Replace this. That. This. Okay. So let's recompile that, and that is bizarre. Something with a blob. This is actually very interesting. So red segmentation flow, yeah, exactly. Right, so there's something with the blob that breaks it now. Like, what the fuck? Maybe blob is too big. Too big for what, though? Too big for what? I don't quite get it. Red sig falls is super rare and dangerous. Yeah, exactly. What is... Ah, that's so bizarre. Alright, so because, like, bruh, that is annoying. Do I have, like, a zero sum? Fuck me. This goddamn escape scheiße. Fuck! I'm sorry. I'm pretty sure it got interpreted as some sort of like a zero code or something. This is annoying, isn't it? I think it's kind of annoying. But no, it shouldn't be interpreted like that. Or should it? Octal. It's also maybe... Fuck. It's also maybe about the percent. It could be something about the percent. But the percent was never a problem for the coin, was it? Percent was never problem for the coin. So if I just run the coin... right. Yeah, percent is never a problem for the coin. Look at that. Because we never really used it in the format, so it is nice. It's totally fun. It's totally fun. So could be string terminator, but I don't think it is considered a null string terminator, because yeah, they double escaped. They're double escaped, so it's not a problem. It shouldn't be a problem. So I don't think it is the case, but it's actually kind of new and kind of bizarre. So let me try to maybe test that somehow. We can try to remove this thing. Yeah, it segfolds right away. Actually, it starts to segfold like around here. And I don't understand why. I don't understand why it is like that. That's so bizarre. So new lines. It actually goes... Okay, so it tries to go to the next line or something. Is that because it overflows X? It could be because it overflows... But I mean, like we check for the overflow for X. We check for the overflow, so it shouldn't be the case. So why is that? Let's reformat. So maybe it's something with the pixel. Such a fucking pain in the ass. All right, wait. All right, so GDB colloc. I'm also a little bit tired already, but I mean, okay. Okay. Okay, so the fact that it fails somewhere here is actually quite good, I think. I think it's actually quite good. I see. So, oh, I see. It makes so much fucking sense. Okay. It's fine. I see what is going on. It's just like I has to be now less than the amount of digits, which is 8. Okay. That's it. That's literally it. So it's just like, yeah, that explains it. This time it does make sense. Okay. So if it's less, and we can, yeah. So I forgot one boundary, effectively. I just forgot one boundary in here. Right, so now let me try to do this kind of thing. Right, so let's recompile the blob. The blob recompilation. The blob recompilation. Okay, clear place. It's a pretty huge blob. I don't really like how huge it is, but it is what it is, and it is what it isn't. Alright, so what do we have? Are we ready, chat? Are we fucking ready? So, yeah, there we go. You can barely see what the fuck is going on in here, but that's fine. It's actually fine. But yeah, so it doesn't print everything. Right, it doesn't print everything, but it's actually very close to what we want in here, honestly. And I wonder if I can go now further. I wonder if we can now go a little bit further. Can I get rid of all of these things? because effectively it would allow me to sort of like compress this entire stuff a little bit like that. Honestly, okay, so it doesn't like something, so it produced an error. So you can't do it like that, so you probably have to do it like this. Honestly, like, you can actually accept it as a digit, so it's not that big of a deal. What you don't like, bro? Doesn't like it, motherfucker. Motherfucker doesn't like it. Oh, you can't probably do it like that. Okay, fair. Yeah, you can't do it like that. So we can maybe move some of that stuff. Anyway, so I want to apply the idea that I had in here, right? So that if any of these things happen, all right, so the first thing you do is just you print the backslash, and then honestly it's not gonna yeah, it's not gonna work in case of n. All right, it's not gonna work in case of n, so it's not particularly great idea to do it like that. Yeah, so I think it's a mistake. I think it's a mistake. But it's already basically in the right direction. It's already basically in the right direction. And yeah, so let's move further. Let's keep moving further and further. Oh my god, my Emacs are just stuck because of this shit. I wonder if I can do a very interesting thing. So essentially inline font into here. You know what I'm talking about? Like inline it directly. So because one of the things you probably can do, I remember seeing that approach in knob.h. What was that? Di append menu. Di append menu. And I think it's not di append menu, but in some places where I used. So yeah, this is what I'm talking about. Something like this, because I can always just do int. All right, and it's an array of ints. And then I can say, okay, so this is what I've got. And I can then just literally inline this thing instead of a font. All right, can I do something like that? That would be kind of cool, honestly, if I could do something like that. Look at that. I think that's pretty cool. Inline font array would be nice. Yeah, I know. I know. Okay. So, yeah. Something like this. And obviously, let's put it like that so we can see some stuff. All right. So, and yeah, let's reconfigure the blob. All right. So, replace. Query new line /n query. That's a, oh my god, I see what's going on. Another include. Maybe I need to automate that somehow. But I'm already tired. So //. Replace new /n. Replace quote like this. Like this. And all right. Yeah, there we go. Something like this, right? You can enable printing the entirety of this thing simply by removing that limitation that we had, but it will make it unreadable completely. Where is the limitation? Yeah, so basically remove this thing and it will print the entirety of this thing, but it's gonna be too huge. right? So it's going to be too huge, so you won't be able to see that. So I need to spend some time basically minifying the whole thing. But the idea of how to implement it, it's already there. As you can see, it's effectively that, right? So you can just enable printing itself, and it's kind of like a clock. So my idea is I'm gonna minify that already off screen, right? So I'm gonna fully minify that off screen. I will see what I can do in here, and then I'm gonna offline record like a footnote demonstrating this entire thing. So you will be able to see, right? So the final result already on YouTube. I think that's a good approach, right? So we sort of like outlined how exactly you would do something like that on the stream. And then like all the routine part, all the grinding, I'm gonna do off screen already, so not to bother you. So, all right, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you all. Mwah. Alright, this is the next day, so I had a little bit of a sleep, so I'm ready to continue developing this thing. I actually decided to continue like developing it online, because as I was sleeping, I actually got a couple of interesting ideas. Right, and I also, like after I slept, I decided to see like how exactly those JavaScript developers implementing this Quine, because this Quine is actually kind of short. Whatever we came up with is actually kind of big, right? So apparently they used some sort of a trickery, right, to make it shorter or something like that. Maybe they used like something that comes with the browser or whatever. I looked into that and I noticed a really weird thing, right? So at the top, they define R, variable R, which is obviously a lambda. So you can clearly see that it is a lambda. And then within the body of the Quine, they are using backticks, and within the backticks, they're sort of embedding R. I'm not a JavaScript developer. I'm not familiar with JavaScript, but that particular trick seems a little bit sus. So what I did, I opened like a Node.js. I decided to define this like fat arrow function, right? So let's actually say console log, and we're gonna say hi in here. So if you call this function, it says hi. What if now I will try to embed this entire thing like, what? So JavaScript fucking allows you to take a lambda function and get its textual representation. How is that different from if I used like something like embed? How is that? That is cheating. Those goddamn JavaScript, they're cheaters. This is not a real Quine. This is not a real Quine. Like it's a fake Quine. God freaking. And let me tell you, those JavaScript developers are like that at everything. They are like that at everything. They're constantly deceiving you. They're constantly cheating. They might tell you that, oh, these days you can develop native applications in JavaScript, and then they ship an entire fucking browser with their native applications. They are like that at fucking everything. I'm fucking telling you. I'm fucking telling you. So, okay, how am I gonna compete with these cheaters then? Like, how am I gonna compete with these cheaters? Like, I was trying to be intellectually honest, and I honestly developed like a proper Quine, right? So here's my proper Quine. It doesn't use any trickery that allows you to read its own source code or anything like that. And it turned out a little bit big because that's how it goes, right? If you intellectually honestly tries to implement a Quine, it becomes a little bit big, right? So I can't really implement it like small like that. So I guess the only way to compete with cheaters is by cheating yourself. So let's actually try to maybe implement a Quine with embed and see how it goes. Maybe that is going to be easier, right? To be fair, embed is a C23 feature, right? So C23, and to be fair, I never used it. I never used that feature, and I think this could be a good opportunity to at least explore it, all right, and see how it works, because I'm also kind of curious about it. So let's go ahead and do that. And maybe after we implement like a, sort of like a fake Quine, like a JavaScript one. Maybe we can try to implement more sophisticated one, a real one. It's going to be bigger, but because it has a bigger surface, we can do something more interesting with it. For example, an analog clock instead of a digital one. Right. So since the actual honest Quine is going to be bigger, we can do pretty cool stuff on it. Right. So we'll see. But first, I want to try the cheating Quine. Right. So I'll go ahead and do that. So first of all, let's Google up how you do embed. Right. So C23 embed. So is there any information about this marvelous feature? So we have CPP reference. So let's actually take a look at that. So today we cheat, today we cheat with your mom. Okay, so embed is a preprocessor directive to include binary resources in the build, where resource is defined as source data accessible from the translation environment. Very interesting. PP token. What the fuck is PP token? Freaking ISO committee, I swear to God. What the fuck are they doing in that committee? They're just having fun, honestly. They're just having fun. We have PP tokens. Is there any examples on how to use this shit? Okay, so you just like literally embed. And I wonder if, right, so we have just Quine. Let's create like a cheat, maybe Quine cheat.c. So in here, I'm gonna just include stdio, and maybe what we're gonna do is src, and so since it's a preprocessor, by the way, it probably means that it has to occupy the entire line, which will make it a little bit easier to, a little bit difficult to actually format things, because like you won't be able to have anything after like after the file path or anything like that. So you can actually have some stuff in here, but I mean, it's going to be interpreted as parameters of the preprocessor. So that could be a problem, but whatever. We'll see. So I'm going to actually embed myself. Can I just embed my own file? That would be interesting. All right. So, and afterwards, can I just print this entire thing? Maybe without any line or anything like that. Right. So, and of course, here I'm going to return just 0. Okay, so let's go into the nob.c, right? So this is a nob.c, and we have Quine cheat, right? So Quine cheat, and if I try to recompile this entire thing, so embed invalid preprocessor directive embed, is that because it's not C23? How can I say, bruh, compile with C23? Is that a thing I can just do somewhere here? So maybe something like std c23. Is that something that is already available for me? So unrecognized c20x. Okay, so it's not really finished or anything like that. Invalid preprocessor empty scale. Okay, so I suppose you have to like literally provide. Yeah, so PP tokens. I would expect that PP tokens is a preprocessor tokens. So that's a little bit bizarre. Preprocess, it doesn't really work. So that is bizarre, my friend. Is that because I'm using GCC? What if I use Clang? Maybe Clang is capable of doing that. Oh shit! Almost like it does. No, I did everything correctly. So embed. So it doesn't work for my thing. So what if I just like do Quine cheat.c? So yeah, it is not available. So okay, so let's see if I can do Clang embed. So for C and C++, is it not implemented in the latest compilers? Is it not implemented in the latest compilers? I don't really know. That is it's kind of bizarre. So do they say what's going to be the command line? What's going to be the command line? Clang embed dir. You have to specify embed dir if you want to do that. Clang or literally other compilers. So it seems no compiler. Really? There's not a single compiler that supports embed? Compiler supports for 23 and embed? No. How? Isn't it like the easiest feature to implement? Or am I missing anything? What the fuck is going on? What? Excuse me? So, like, how can we allow those cheaters to win then? What the fuck? To use the standard JS implement. Alright, so apparently we can't even do that. We can't even cheat. We're at such a disadvantage that we can't even cheat. We have to actually honestly implement this entire shit, apparently. Okay. So that's a little bit bizarre, but I mean, sure, we can probably live with that. Anyways, so let's go ahead and just like remove this kind of stuff. So yeah, it is what it is. I'm pretty sure those goddamn JavaScript developers, they paid ISO committee, so they stole on actually adopt. It's not really ISO committee. So they probably paid to the C compiler developers. They paid to the C compiler developers to actually stall the development of this critical feature, so the C developers cannot cheat and cannot compete in Quine development with goddamn JavaScript developers. So, ISO paid by big JS Confer. Exactly. That's literally what happened. That is literally what fucking happened. Anyways, so I guess we have to go back to our original Quine, right? So our original clock. So yeah, we have a little bit of a bullshit in here. So this is basically the leftovers from the yesterday where we tried to, you know, implement this entire stuff. So I kind of want to start over with this kind of thing. So let me quickly invoke this entire stuff, and I'm gonna just like remove this entire thing. So Clang, we don't need this entire stuff. Right, so it's a little bit inconvenient, in my opinion, to recompile this blob over and over again yourself. Right, so it would be kind of better if we automated that, right? So essentially how we can automate that, we can probably just write some utility that reads the source code of this entire Quine, right? It reads the source code of this entire Quine, right? Finds the question mark and embeds the compiled blob into the question mark. So essentially, I think technically the utility is going to implement like this Quine, but partially. We don't even have to implement it as a separate executable or anything like that. We can actually write that code inside of nob.c. Right? We can literally just write that code in here, and it's going to be part of the building system. So this is one of the advantages of using C as a building script. You can literally have like actual algorithms in here that do shit. Yes. Okay, so let's implement some sort of function, maybe like a compile blob, right? Or maybe let's call it compile Quine blob. So here is going to accept, so maybe output path where exactly you're gonna output the you know, compiled blob and stuff like that. And here we're gonna accept the input path, like so. All right, so essentially in here, what we can do, I'm gonna return maybe Boolean, because we're gonna be reading files, so reading files may fail. So this is gonna be false for now. And before compiling clock, what we can do compile Quine blob, and let's say that the output is going to be clock blob. Right, clock blob. Right, so we're taking this as an input, the original thing as an input, and we basically turning it into that. Right, so we compiling the blob with a question mark. So, and if it fails, of course, we just fail the entire thing. And now instead of compiling this thing, right, we're going to be compiling this thing. So we add an additional sort of pre-processing step. Right. And how we're going to be doing all of that in here? So let's actually maybe read an entire input file. Right, so in nob.h, nope.h read entire file. There was a function in here. So it wants the string builder. So let's actually define the string builder on the stack and give the pointer to this thing in here, right? We're reading from the input path. And of course, if this entire thing failed, right, if it didn't return what we expected, we just return false. There we go. So now, what we want to do. We want to open the output file for writing, right? So this is going to be output. We open the file output path, and we're opening it for writing with the binary mode. As far as I know, on Linux, it doesn't really matter, right? So it's something that kind of matters on Windows, but we're not using Windows, and I think these days it doesn't even matter on Windows either. So I don't really know what the fuck this thing means anymore. Right, it has something to do with processing new lines or converting new lines or something like that. So binary mode says like don't do anything funny with new lines, and that's why I always enable it, but I'm not really sure what the fuck it means these days. Nobody knows. Nobody knows. Okay, so in case of an error, it probably returns null. So in this case, we probably want to say could not open file for writing or whatever. Yeah, it's something with /r/n, I don't really know. So nob log nob error, and we're gonna say something like could not read file s because of s, and output path is the first s, and the second s is going to be str error null, and we're gonna just return false. There you go. So and somewhere here we're gonna fclose the output afterwards. Okay, that's pretty cool. So, and what we need to do, we just need to iterate through all of the bytes of the content of the file, right? So we're just iterating through all of the bytes. And so we're gonna do a special thing if we encounter a question mark. So if the items is equal to the question mark, what we have to do, we just have to print the entire blob escaped properly. If it's not the question mark, we're going to be just printing like single character in here, right? So maybe we're going to do fprintf output, print that character in here. Otherwise, instead of question mark, print the entirety of the blob again, right? So it's going to be sort of like a nested thing in here. So it's going to be something like that, sb count ++j. There we go. So this is our sb count, and in here, so we can just say, okay, print j, but we also have to handle some special things that need to be handled, right? Like new lines, backslashes, and quotes, right? So we might as well do something like this. We can switch upon those things, right? We're switching upon those things, and if you encounter a new line, we're going to print instead escaped new line. So it's going to be double backslash and just a regular n, right? And that's about it. We're going to be printing it in the output, and we want to do break, right? And we're going to have three special things that we have to escape. Backslash is replaced with double backslash because we need to escape that, and you know, the quote, the double quote, and that thing is going to be replaced with double quote like this. So, and if we encounter something else, we just don't care about it, right? So we just print it as it is, and that's about it. So I think that's the thing that we want to do in here, right? So it's basically what we do in Quine. It's an interpreter from Quine. So we have a little bit of a Quine embedded in the build system, right? So that's kind of cool, I think. Anyways, so let's actually try to build this entire thing. And what does it say? It doesn't like that it doesn't have a semicolon. There we go. So it couldn't compile for whatever freaking reason, probably because at the end of the compile Quine blob, I returned false instead of true. To be fair, after we close the file, it would be nice to maybe inform the user that we generated some sort of a file, not info, not really info, generated as, and we're going to say output path, right? So that's what we want to do in here. So look at that. So we compiled all the usual stuff, right? Generated clock blob, and then we compiled clock blob. How about that? That was pretty convenient. So if you take a look at the original clock, so there's no blob in here, but then we can go into the build, and within the build, here is the blob. So we automatically compiled that entire blob for us. So, which is kind of cool, and as you can see, it's also compilable, right? So it's also compilable. So I don't have to do that manually. I don't really know why yesterday I was doing that manually. Maybe because I was already tired, right? So because doing it like that is obviously way easier, right? We can even test that a little bit. So I think that would be useful. Let's go and cd into this folder. cd nuts. Sorry. And let's just try to run the clock. Okay, so that seems to be working. So we see part of this entire thing, but we still see, you know, the part of the source code. We can maybe even, I don't know, remove the limitation on the amount of things just to see the entirety of the source code. But the entirety of the source code is actually kind of huge, right? So that's kind of the main problem when you are not cheating when you're implementing your quines. When you implement your quines, honestly, they turn out a little bit big because they are supposed to contain the whole information in a recursive manner. Okay? So anyway, so yeah, so it's gonna be quite big. So the thing that limits the entire stuff, it's actually here. So let's actually try to remove this entire thing, and let's go. I wonder if it's gonna... Okay. Ooh, that's interesting. It actually prints like a new line every time. I see. So it's a little bit weird. It is a little bit weird the way it works. So I'm not really sure. But it, I mean, it prints its own source code, right? So it prints its own source code nonetheless. Though it's still a little bit weird, right? Anyways, so what we want to try to do, output for ends, yeah, exactly, output for ends. Although when I don't limit it like that, it's actually kind of fine, right? So maybe that's totally fine, right? So if I don't limit it, right, it's actually fine. Maybe it's some sort of, oh, I know why. Because there's one single huge line, right, that wraps around. Because of that, the width is actually, the width of the entire thing is kind of skewed, so it's not real width. So for this entire trick to work, all of the output in terms of width have to fit into the terminal. Right, so I understand why it was sort of like drifting around. So that's fine. If we manage to actually reduce the size of this entire thing a little bit, I think it's gonna turn out fine. I hope so. So anyway, so the thing we need to do, we need to actually keep reducing now the size of the code, right? Since we have automated, you know, blob rebuilding, it shouldn't be that difficult. But before I go into that, I think I'm going to simply commit this change because I think it's kind of useful. Right, so implement compile quine blob. Right, in, maybe I'm gonna even say that it's snob, right? Some sort of like a label. So it's a very common sort of convention in commit messages to put some sort of like a label. Does anybody know what's the name of this thing in commit messages, right? So like I see it all the time, I also use it all the time, but I don't really know the name of this convention. Is it called label or is it called the category or something like that? So it feels like one of these things that everybody uses it, but nobody really knows what it's called. A tag, I would call it a tag, honestly, right? So the category. So would it be still valid if in your opinion, if quine outputted the clock source in a rolling window, so you choose the dimension, the source would all be visible, but all at once? I think so. But to be fair, why I don't want to do that is because I want to create a cool demo where I play the clock, then I very epically and very dramatically press Ctrl-C. It has to be extremely dramatic. Then I do ed, test something like C. I literally copy-paste this entire thing like so, press dot, save, quit, recompile the whole thing like so, and run it again, and it reappears again. So this is my final goal, to actually dramatically do this kind of demo. So, and because of that, rolling window is not really going to work for that. So you see what I'm talking about? You see what I'm talking about? So I want it to be like copy pastable to demonstrate, look, it acts like a clock. You control C it, you literally take that output of the clock, you put it in a file, compile it again, and it reproduces itself. I think that is fucking cool. So all right, so let me see. Oh, we got some beats even. Ooh. Void Manger, thank you so much for 100 bits with the message. Mr. Zoni is on fake.js rage today. Damn, exactly. Exposing all of these JS devs and their trickery. Team Scar, thank you so much for Twitch Prime with the message. I just want to wish you all a happy day. Thanks for stream sizing. You're welcome. Thank you. Happy day to you too. Always remember happy day. Cheers, by the way. So okay. Let me see how we can simplify the clock. Again, so the thing we probably can do is just like query replace all of the constants in here, right? So we probably don't need all of them. So, and I don't even use count in here, so we don't need this thing as well. And to be fair, maybe I can just move this font in here, right? So the most important thing here is after you replaced all of the defines and stuff like that, is that the code still works and does its segfault, right? So that's the most difficult part. So I'm gonna replace it with 5. Okay, so that's totally fine. Then this one, we replace that with 3. Boom. And digits count, I'm gonna replace that with 8. Boom. So digits pad, we replace that with 2. Boom. Now this one is now 5, 14, and as far as I know, it's not used anywhere, and this thing is not used anywhere. So now I can just recompile this entire thing, and I don't have to recompile the blob whatsoever. And it actually automatically modifies itself. It's kind of cool that like you reduce the amount of code and the blob also shrinks down, right? It's still kind of big, but primarily because of the spaces. I wonder if I can just query replace actually with the regular expressions and just say, okay, remove all of the spaces, like at all. Will that reduce the size of the blob? It's still compilable, right? So I can take a look at the blob now. Yeah, it's actually much shorter. To be fair, yeah, at some point, we're probably gonna actually smoosh everything together, right? We're gonna smoosh everything together and we'll see how it goes. We can try to run this entire blob thingy. Yeah, seems to be working, still seems to be working. So we don't really need majority of the headers, except maybe time. So there is a little bit of a problem with the time because like it really needs that like a structure definition and I don't really know where to get it. So it's kind of annoying. So yeah, let's actually see if it's going to work. Yep. So now if I try to, oh, I was actually modifying the compiled blob instead of, goddamn it. So now we have a problem that I may accidentally forget and start modifying like a generated code instead of the real code. God fucking damn it. Anyway, so yeah, we need to remove this kind of thing. And let's actually try to do it like that. So did it compile? I think it compiled. It has a bunch of warnings, but we can just ignore them because who fucking cares? Oh, and it's segfaults now. Is that because of the headers? Yes, it's because of the fucking headers. So that is absolutely bizarre. Okay. I remember that. I remember the shit. I'm sorry. So it's less than 8. Yeah. So I forgot that when I actually discarded the previous work, I also discarded the fix for this. Okay. Everything's fine. So it's back. I should probably commit that. Honestly, I should probably commit that. Let me see. So everything seems to be fine. So look at that. Look at it go. That's pretty cool. So I feel like this specific time thingy is going to kind of limit us in terms of like how we're gonna format this entire stuff. I think it is going to be kind of limiting in that sense. So another kind of thing that may help us in here, right? Look at how we actually call pixel with all these parameters. But we use these parameters in only two places. Can we just like maybe make this array global somehow? Right, so can we just make it global? Right, and essentially in here, I can get rid of that. So, and because of that, I don't have to even, you know, pass that digits anymore anywhere, right? So I can just quickly replace this entire thing with nothing. I don't have to pass it like ever. So that's pretty convenient. So we can do something like that. And then it seems to be working. And the clock is, by the way, is still going. It's actually still going. Right, so that's kind of cool. And we can probably even maybe make X and Y global in here as well. So as you can see, so yeah, well, why not just make it global? So we never have to pass it or anything like that. We can even maybe define like this. And you remember the conveys obfuscation. We can even get rid of this thing. So it's kind of the convey obfuscation all over again, honestly. Right, so this is going to be global. So here we probably want to define this thing like that. Right, so the switch can fall through. The switch can fall through, or are you guys talking about something else? Like in here, we don't really fall through anywhere. At least I didn't think so. So that seems to be fine. Everything seems to be fine. I don't know what you guys are talking about. Right, so there's some problems. There's some errors in here. Where are the errors? Oh yeah, so this is because we're passing X and Y to the pixels function. So can I now... Okay, this is a wrong file. This is very important. So I'm gonna quickly replace this thing with nothing. So now we're just using this kind of thing. Okay. Right, so let's try to rebuild this entire stuff. And if I try to run it, okay, that seems to be working. So interestingly, we doing X plus 1 on each pixel. Can we just like move it inside of the pixel, because we have an access to X anyway? Right. You know what I'm talking about? We can just do it in here, right? Who said we can't do that? So that way we don't really have to do that shit anymore. You know what I'm talking about? Oh, except this one. Okay, so if we encounter the new line, we kind of have to reset X, right? So because it becomes like X and we have to increment Y. We can actually also do that inside of the pixel, and we can just check inside of the pixel. Okay, if you are working with a new line, right? If you're working with a new line, you do that. Otherwise, you do that. Yeah, we can do that. Why not? Right, so, and in here, we don't even have to do that. So that's pretty convenient. So I think we can even get rid of these kind of things. Right, so that I think makes it a little bit easier to work with, maybe. Right, so this is gonna be something like this. All right. So, and okay, so that actually simplifies this entire stuff. I really like that. And so this one is just like, honestly, in case of new line, print new line. So the only reason why we needed this case is because we needed to increment Y, but we kind of moved that logic inside of the pixel. So we don't really need this thing anymore because it's going to be handled by this one. Yeah, we don't need that. Okay, that simplifies it even further. Damn, okay. So that's already pretty small. Wasn't the reset before pixel call after, or rather than after? No, I think it has to be after pixel call, because yeah, it doesn't really matter, honestly. It doesn't really matter because of this condition. Have you tried to get rid of the time using file? This is a cool idea. Okay, so let's give it a try. Can I actually do that? So if I remove time, right, so it's impossible. Okay, and then now in here, I wonder if I can just in build. I didn't know about this kind of thing. Okay, so include time.h. Oh yeah, so I probably have to have it as a separate parameter. Okay. No such file or directory, so it doesn't really work at all. I wonder if I can maybe just do it like that. Okay, thank you. Thank you so much. Okay, so VIP, that is actually VIP worthy. So the entropy shard, you are VIP now. Thank you, thank you. I didn't know about that. That's actually a super cool trick. I mean, and if somebody says it's cheating, this is the people we're talking about, right? So it's JavaScript developers using JavaScript trickery with this kind of stuff, and you accusing us of cheating after that? By the way, I'm being absolutely ironic. This thing, the person who developed that is absolutely cool, right? It's still cool, even though it uses like a little bit of this trickery and stuff like that. It's still super cool. I'm being ironic. I'm actually joking. Don't get me too serious. Okay. So obviously I'm being ironic, and it is still freaking cool. It is still freaking cool. So yeah. Let's see what we can do next. It's actually super cool that I can just do that. Damn. So can we simplify it even further? For instance, maybe we can we actually embed the tokenizer? Damn. So now we have actually pretty cool opportunity to just format it as a square, simply format it as a square, right? And we don't have to even worry about the preprocessor or anything like that, because we don't have a preprocessor here. So we can just embed the STB lexer, the C lexer, and just like do this kind of thing. So even like in Knob, we can do pretty cool thing where first we reformat the tokens of QBlock, right? We reformat the tokens of QBlock, then we compile the blob, and then we compile this entire thing. So we can actually have 3 steps in here. This is super cool, honestly. This is super cool, and I really want to try to do that. Anyway, so let's actually do something like format tokens. Format tokens, and we're gonna accept the output in here, right? So this is gonna be output path, and here is gonna be the input path. So yeah, let me see. So the first thing, to be fair, let's just call this function as it is. I don't want it to create anything new yet. But I want to see how effectively it splits the tokens and everything. So the output is supposed to be somewhere build clock formatted, right? So formatted.c, and if it doesn't work, we're gonna just return something like this. Okay, so let me go to Conway and steal the STB lexer. Conway. Don't I have Conway? Okay, so I'm in the wrong folder actually. Conway. Where is the STB lexer? Where is it? Where is the STB lexer? Okay, so here it is. That's pretty cool. So I can literally include this entire thing into the build system. How cool it is! Like, I'm using C as a build language, and I can embed a C lexer into the building process. Can your freaking CMake do that? I don't fucking think so. Probably it can, but I mean, you just call the external things or whatever. Let's include stbc lexer.h, right? So that's what it's called, stbc lexer. What's the implementation? So here is the implementation of our nation. So let's go, let's copy paste that. How do you even use that? So the first thing we need to do, we need to read the entirety of the input path, right? So that's what we need to do. So it's pretty easy, you just do that. So, and by the way, read entire file actually allocates memory, right? So in here, we're leaking a little bit of memory, but because the build system just fires and dies, we don't give a fuck. we just leaked a little bit of a memory, but then the application, exited, and the operating system actually delocated all the memory. So I don't give a shit about, leaking memory. That's it. Like, I don't give a shit. I leak a little bit of memory, deal with it. So I have 8 gigabytes of RAM. I paid for all 8 gigabytes of RAM. Now, how are we going to be approaching that? So I don't remember how to use this entire thing. I feel like I want to steal some stuff from Conway. Let me see. So there was maybe some stuff in here. Okay, so it was not in here. Image format. So that's where it was. Okay, so first of all, you have to create the Lexa, and you also have to allocate a little bit of memory for the string literals, right? So string literals and stuff like that, and then you just initialize this entire thing. Okay, so fair enough, we can do that. Fair enough. So we also allocate it on the stack or whatever. Okay, so afterwards, we are going to be iterating the tokens, right? So we're iterating the tokens. So that means while we do have le token, right? So this function should return true, and that means in here, this is how we get the actual textual representation of le token. So that's what's going on in here. So we can actually steal a little bit of that. And in here, as you can see, we're just printing all of these things. Okay, that's pretty cool. So we'll give it a try. So if I try to run this entire thing, and there we go, we actually split this entire thing into le tokens. So all of that stuff is split into le tokens. So how can we even format them? So as we iterate them, we probably want to maintain the x, right? So essentially this x. So we print le token and we increase the x by the size of le token. So interestingly is that, okay, we can just like stitch together, we can concatenate tokens as they are, right? And for example, in here, if x is greater or equal than 80, what we have to do, we have to actually print new line, right? So it's going to be print f a new line, and we reset x to 0, right? So that's what we can do now. That's pretty cool. That's pretty cool. But as you can see, it actually merges together these kind of tokens, which is obviously incorrect. So we kind of need to actually store the kind of the previous token. And if the kind of the previous token is identifier and the kind of the current token is also identifier, we have to kind of split them with a space, right? Separate them with a space. So let's actually introduce something like a previous kind, right? So this is a previous kind, maybe originally is going to be something like 0, I don't really know. Okay, so what we can do, we printed the token, and so we can even check it in here. If the previous kind is equal to, how do you denote identifier? I don't even know how do you denote identifier in STB. So I think it's something like ID. All right. So where are the token kinds? Here they are. Clex ID. If the previous kind is Clex ID and the current one is also Clex ID, but the question is, where can we get that thing? So it's probably somewhere in the STB Lexa, right? So, okay, so I suppose that's what it is. And the L token is also Clex, right? If it's also Clex, we just have to print an additional space. We just have to print an additional space, and that is it. That is it, right? So, and afterwards, we just save the previous kind with L token. So to be fair, since it's called L token, maybe it should be called previous token, right? So we have current token, previous token, and then you update it and stuff like that. Okay, so and afterwards, I suppose maybe we can print a new line in here just in case. So in the login, it looks a little bit nicer. We'll see. So, and look at that, it's actually much better. So it actually splits those things, and it's not even that much. Chat. What if we achieve like a good, reasonable size even without the JavaScript trickery? That would be an ultimate win. Not only we replicated that in ANSI terminal in C without any freaking browser, but we didn't even have to use this JavaScript trickery. How about that? I bet JavaScript developers didn't expect it. Anyways, so but I mean, this doesn't include the blob. That's actually very important. This doesn't include the blob. With the inclusion of the blob, it may become kind of interesting. Okay, so let's actually see. So here we have to return like a false or something. Maybe we're not gonna have a new line in here. Okay, so I suppose now what we have to do, honestly, we have to just query replace printf with fprintf output like this, right? So now it just outputs to some file. Now we can just like redirect all of that into the file. And let's just open the file. So this is going to be file output f open. So this is going to be output path writing binary, right? So and if output is equal to null, can I just steal the error logging because I don't want to type it? I need Copilot. Can anybody give me access to Copilot? They don't want to type this shit. I think I'm starting to understand people who use Copilot, right? So sometimes you just don't want to, like, I know what I want to type, just type it for me. Anyways, but I know how to copy paste, all right? I know how to copy paste. I can still do that. All right, so let me see. So is it working? Is it working? Okay, could not read file clock formatting. So it is for, that's a little bit bizarre. So if I do something like, so this is supposed to be the output. All right. So what you don't like? I don't get it. Could not read file. Oh, bleed. Oh, I see. Bleed. Build. All right. Okay, so and then it failed because it returns false on exit. It's not supposed to return false on exit. Okay, that's cool. So if you take a look at the building here, right? So here is the formatting. Okay, so that looks cool. That looks cool. We can simplify it even further. I can see that we can simplify all of that. It's gonna be super cool. Now, if I try to maybe put a blob in there. Let's go into the knob.c. So now, instead of the input, we are, instead of like the usual thing, we are using formatted. And then we compile in the block. Okay, look. We take the original clock, we format it, then we take formatted and we blob it, right? And then we take the blobbed one and we compile it. There's like 3 steps in here. There's 3 steps in here. Okay, so let's see if it's going to work. So undefined reference to main. This is actually bizarre. Like, what the fuck? Excuse me? So it couldn't compile the main? Like, what the fuck is going? Oh, it's empty. It's not flipping empty. Well, what the fuck just happened? Did I do a fucky wucky? I feel like I did a fucky wucky. That's absolutely bizarre. All right, so if I take a look at the compilation, so it's generated blob. So maybe we can also say that I forgot to close the file. Professional software developer, by the way. I mean, like, why is it not closed upon exiting the scope? Where is my C++? Where's my fucking C++? It's supposed to be closed on exiting the scope, okay? Anyways, so knob log knob info generated as output path. Right, so let's go and just do that. Alrighty. Oh fuck, mate. Fuck. 63. So another thing we have to handle in here is numbers. I'm telling you. So class ID and also class, I suppose numbers, but okay, int lit. We can try to handle that. So we can say or priv token equal int or el token. Hola. Int lit. So maybe it would be actually good to separate that into a function, because like if you add another kind, so it will grow like quadratically. We can do something like this: is unconcatenable, and we accept le token, el token. We just take this entire thing and we just do something like this. We just return the result of that, which enables us to say is unconcatenable previous token, right, this one, and this one is also is unconcatenable like so. Let's go. Okay, so what you don't like, prev. Okay, so this is not prev, this is just the token. Okay, so it sheds with a little bit of warnings, but it compiles. Okay, it sheds with warnings, but it compiles. Let's actually take a look at this entire thing. Let's take a look at the blob. Okay, that's very interesting. So it's just like bulging out, sort of speak. It's like bulging out. So yeah. I wonder if I run this entire, this motherfucker works. Okay, so it shifts around because it's bulging out, so it doesn't compute the size correctly, but it works. It actually works. So we can iterate on this entire thing and make it smaller and smaller and smaller, and we don't even have to sacrifice readability that much because we have automatic formatting. So that is actually kind of cool, right? So I can just work on clock like this, right? I can do things like, for example, I can remove void, but I don't have to like remove formatting or anything like that because it's done for me automatically. That's kind of perfect, honestly. It's kind of cool. So I don't know. I can maybe even do things like that, right? I can move font in here. Does it still compile? Yeah, it still compiles. Can I query replace font with just F to make it shorter, and maybe digits with D to make it shorter as well? So, and I recompile this entire stuff. And if I take a look, so the more I remove, the more the like blob itself also reduces, right? The more it reduces as well. So that's kind of cool. I wonder if I can take str and actually put it at the top. Maybe I can even like remove const or something like that. So how is it going to look like? Okay, so if I take a look at the blob now, so it's kind of at the top, so we can kind of control like where it goes. And is it still working? Is it still working? It is still working. It's kind of bizarre, right? So because it's bulging out, but I mean it's still working. That's pretty cool. So I'm thinking, how can we make it more compact, if you know what I'm talking about? What if as we blobify this entire thing and we encounter a new line, what if we literally put like an extra new line in here, like split it like that? That may overcomplicate our encoder in the actual application, but it may allow us to actually split this entire stuff a little bit nicer, like so. You know what I'm talking about? It would be nice if you know, the build system actually did something like that. Let's split it like this. You know what I'm talking about? Int to hex with font. Int to hex into hex. You mean you encode this thing with hex or some? Actually, encoding this thing with hex is not a bad idea. That eliminates the problems with the escaping and stuff like that, and that simplifies the decoding and everything. So the decoder in the main application becomes shorter, but at the same time that inflates the blob, right? Because now you have one character per byte. if you do hex, you have 2 characters per byte. You simplify the encoder, but you inflate the blob. So it's kind of like cancels out, so I don't think it's a good idea. So I think this is a good way to encode this entire thing. Actually, let me try this idea super quick in a knob. Knob.c. Right. Essentially, right, if I encounter a new line, I'm gonna add quote, actual new line, and another quote. Is it going to make it look a little bit nicer? Blob. Holy shit! That it's not going to work, by the way. Yeah, so if I try to run this application, it actually, you know, conflates it like that. It concatenates all of that, but I mean, it's not bad. It's not bad. And as you reduce the size of this thing also reduces, right? It's just like 2 halves. Right. So I wonder how can we actually in the clock itself facilitate this kind of thing. So as we print the blob, we can just extend this entire thing. Honestly, we can just do pixel. Right, so we print backslash, but we can now print you know, just a quote, then actual new line, and another quote to close all of that. All right, I think that's what we can do. Now, if I try to do something like that, and if I try to, okay, so it was actually easier than expected. Okay, cool. So do we still have a limitation? We do still have a limitation on like how much we can print. We still do have a limitation on how much we can print. Now if I, all right. Okay, look at that. So it prints the entirety of the source code. All right. It kind of, because it doesn't have like this new line, maybe I should add a new line somewhere. Just a second. If after formatting in knob.c, where is the formatting? Where is the formatting? Format tokens. So at the end of the formatting, I do not add any new lines. What if I add additional new line in here after formatting? So is that going to be a good idea? So that results in this additional new line, which is fine, not that big of a deal, but in a blob, it results in this kind of weird shit, which I do not particularly like. But maybe that is fine, because then afterwards there is this additional new line. Maybe the way we're gonna resolve that is actually printing that in the decoder. Who said we can't do that? So after, yeah, just put it in here, like additional new line. Yeah, okay, so that works. Ah, fuck. So I don't really know how to do that. Ah, if we're gonna be doing additional new line, that means I just have to do +1 in here. Okay, so that makes sense. Sure. Okay, so I just want it to be like that. Okay. Control C. AD quine2.c. No, let's actually call it something different. Okay, so one more time. Right, so it is a clock, it is working, it is twerking. Control C, ed clock2.c, A. So A means that ed goes into the insertion mode. I select the entirety of this entire thing. I copy paste it. I press dot. Dot means that it is gonna save it into the buffer. I press W, it saves this into a file. Okay, so then I cut clock2. So here's the source code. Now, if I do cc, I have to include like a time.h, and this is gonna be clock2. And I run clock2. Fuck you! This is how real Quine clock has to be done. It's not JavaScript trickery, right? It's a real Quine, right? And you can actually verify that it works, and it's ANSI terminal. It's in ANSI terminal. It doesn't depend on overbloated browser or anything like that. Fuck yeah. Fuck. It's pretty big. It's pretty big, but because this is a real Quine, it actually stores its own source code. So since we're cheating, but I went to look up, and apparently GCC with std GNU 99 and GNU 11 that would cut down on escapes in the blob slightly, I think. I don't know, I think escapes here are actually fine. But anyway, so can we actually shrink the source code a little bit more? That's the real question I have in here. Can we keep shrinking it up? For example, one thing I was thinking about, what if I just query replace pixel with simply p? So now it's p. So if I try to run it, it's a little bit bizarre. Okay, so that's really strange. Why is it rendering it like that? So clock, it was actually better. It was actually better before. That is weird. It's kind of, yeah, because as we format all of these things, it's actually not taken into account like properly. Dang. So I don't really know. Maybe we can, what if we actually put this entire thing in the end? To be fair, we can actually kind of put it anywhere. Okay. So it's not really visible in some places where it's not used. But we can kind of extern char. But that increases the size of the source code, so... it's not, it's SRC, Jesus Christ. Okay, so that's... Yeah, it's not better. But maybe it is. Maybe it is. Okay. Let me see. Can we maybe actually rename it to maybe S? In how many places it is used? Yeah, maybe that will actually reduce it. So we can maybe define I and dx in here and get rid of that. We can actually start getting rid of the curly braces. How about that? Let's actually get rid of the curly braces. So for example, we don't need these curly braces. I'm pretty sure about that. So yeah, there's a little bit of a bulging in here, and it is a valid bulging, I think. So let me take a look at the blob. Yeah, so I'm still not kind of sure how to do that. So one way we can do that is that as you encounter the char, just add a new line in here, but that new line has to be done at the level of the formatter then. So I'm not really sure. Maybe it has to be reformatted one more time, but if you reformat this thing, it's not going to be Quine anymore, right? So it's not going to produce itself with the same formatting. So it's actually kind of not sure how exactly we're gonna approach that. So yeah. So this is I. This is another I in here. So that means we can kind of get rid of this thing, but we're already reusing I. I see there are spaces that are part of some digits, because that's what happens to be at that location. Just a second. I see there are spaces that are part of some digits because that's what happens to be at that location. So nothing is getting colored in that case. Maybe it would be better to emit ANSI codes to change the background color instead of text color, so that always have something on the screen. Okay, sure. Let's actually try to do that. I don't remember how to do that, so I'm gonna ask ChatGPT. So because like it's, yeah, I see what you're talking about. Like it's really difficult to read this clock, and I do agree with you. Okay, so here we print red text. Text with red foreground. How to print text with red background and black foreground. Okay. So yeah, so this is probably what we want to do. I'm gonna just blindly believe this thing, and hopefully that is going to do the trick. Okay. So, but it's actually not. Yeah. Let's leave it as it is. Let's leave it as it is. I think it's fine. It's much better. So yeah, that's pretty cool. All right. So to be fair, it would be nice to commit whatever we have. Right. So let's actually get rid of that. Let's get rid of that. Let's get rid of that. Right. So what did we do in here? Actually, working clock. Actually, working clock. Damn, I'm already streaming for 1 hour. I think the time has come to make a little bit of a break, chat. I think the time has come to make a little bit of a break. So I want to make a cup of tea. And after I made a cup of tea, we're going to continue shrinking this entire stuff down. Right. So there's a lot of things we can simplify. For instance, here's the switch case that has only 2 branches, which actually means that we can do something like this. So this is going to be 63. All right, so we don't need that. And this one is going to be just else, right? Is it not going to be else? Yeah, so this is going to be else, and that's basically it. There we go. And if I try to do that, it becomes shorter. Right, and to be fair, by the way, this body consists of a single statement, which means that I can get rid of this thing. I can actually get rid of this thing. Right, and since this is a single statement, I can get rid of this thing. Oh no. And this is a single statement, I can get rid of this thing. Yep. Yep. So I can do all of that. The fuck is wrong with me? Honestly, wait a second. Can I do some, I probably can't do that. Fuck. So I need to factor all of that stuff out. But anyway, yeah, so that becomes shorter, and that still works. That still works. Right, so we're slowly obfuscating this entire stuff. Slowly obfuscating. Can I obfuscate even more? I think that's about it. So that's everything I can do in here, or some other places. And to be fair, like, this doesn't really matter where it is located. We can always locate it somewhere here. Doesn't matter. So I'm thinking, what if instead of like SNs and I's and J's, I would literally have like a pointers to a string in here, right? For example, I will need 2 of them, right? Because I don't want to lose one of them. So I can do the outer one and the inner one, and both of them are sort of like integers. And essentially here, like, I don't want to collect the, like, I don't need to know the size. So in here I can say the outer one is equal to S. Then while you have something in S, it's null terminated, so that means it will stop at the end of the string. And in here I just like increment this entire thing. Right, and now instead of like SI, what I'm doing, I'm just referring to SO like this. So that actually makes it shorter. I really like that. Wait a second. So that's pretty cool. Which enables me, by the way, to put these things in here. All right. Does it still compile this? Just a second, because I'm going. Okay, so it doesn't compile. So SN, yeah, because of these things. So I need to also, you know, fix it. SIS. While you basically has something in here. So SI++, and it's SI like this. All right. Can you simplify this? Okay, that's actually super cool. This is actually super cool. Can I do anything else in here? I don't think so. That's about it. That's about it. All right. Okay, so because this thing is a little bit too huge, but it's fine. All right, so that's I really like that. Honestly. To be fair, this kind of stuff, can we can effectively move this kind of stuff to maybe here, slip 1, and we can effectively get rid of this thing at the end. So, and this thing is happening at the beginning, but who said we can't do that at the... Can I freaking call this something like a get display? Since it's a D, let's call it get D, or maybe GD for short, right? So this is a GD, so that's what we're doing here. We do GD, so you do GD at the beginning here, at the first iteration, and then you do GD after a slip. And because this becomes a single statement, I can get rid of the... The fuck is this? To be fair, this shed is surprisingly small even when not obfuscated. How the fuck is it so small already? How? Like, it's not obfuscated yet, by the way. This is supposed to be human readable. I forgot one thing. Remove int, remove return, and we don't even have to worry about returning code because this is an infinite loop. It's not supposed to return actually. It's not supposed to return. This is not obfuscated, and it's actually bizarre. Okay, so let me try to do that. Okay, all right, that works. That unironically works. That still works, and it becomes shorter and shorter and shorter. So I'm not sure how to make it even shorter. So one thing we can do is maybe scale the digits. So that's one thing we can do. Right. So that's one thing we can do. So which is pretty cool. So try to divide x and y by 2, where you check in is it colored or not. This will make 2 by 2 pixels and will look better in my opinion. So divide x and y by 2. Divide. We can give it a try. Okay. So divide by 2. So this is x. All right. And when I do y, all right, so this is y. I'm not sure if it's maybe it's fine. So okay, so this is y. Let's do that. And I see what you mean, but I'm not 100% sure how exactly to pull that. Okay. That is fucking epic. Can we offset this motherfucker a little bit? Who said that? FXS. Right. So no. Who suggested to divide? Okay. Wavemand. You get the IP. That's a good idea. That's actually a very easy, cool hack. Right. So I really like that. Thank you so much. Right. So I feel like one of the things we can do is, can we add one? Right, if I try to offset this thing like that, is it going to work? What did I do? Why it didn't work? What? So this is 2. Okay. And this is the second one. All right. So that, so what if I subtract instead? So I just want to establish how you even, okay. You need to increment x and y by 2. I want to actually bring it down a little bit, so that's what I'm trying to do. So if I just do something like 5, right, I'm a little bit tired. Okay, so that's actually perfect. So for whatever reason, it's actually bigger in here, right, but that's fine, I guess. I guess that's fine for now. It looks all right, that's for sure. It looks all right. So now I can maybe do 4, and we can, yeah, it's pretty cool. Roundest issues, yeah. So that's probably roundest issues, because the amount of rows is odd. The amount of rows is odd. So that's basically. This is already cool. This is already fucking passable, honestly. Like, I don't know if I want to continue like messing with that, but that's already kind of passable. So yeah. So there's that. Oh. Damn, bro. The first clock line is tripled. Yeah, I know. It is tripled a little bit, so, but I don't really know if we can do anything about that. So yeah, well, let's actually try the test. Right, so you have a clock like this, right? So you press Control C. Do we have clock 2? No, we don't have. Ed clock 2 dot C. I'm going to select this entire thing, put it in here, boom, dot save clock 2. All right, CC, no warnings, right? So this is no warnings, include time.h, and then clock 2. Can you see what is going on here? Clock 2 C. That is so fucking cool. It's like truly fucking quiet. That is insane. Such a freaking cool quiet. So yeah, it's like straight up quiet. Yeah. You try several different widths in formatting to make it more like rectangle. That is a good idea. So let's give it a try. So formatting. Format. So what kind of width do we have? So it's 80. We can maybe try to do 75. Yep. That didn't work. 60. Oh, I'm looking at the wrong. Okay, so I'm looking at the wrong one. So, oof. Yeah. So it's probably, what about 75? The one that I didn't see in here. Yeah, so that's too small. 80. We can actually maybe wiggle around. That's bizarre. Wait a second. Yeah. So yeah, I see. So for some of them, it's kind of like this. It's kind of hard. I feel like the formatter has to be kind of aware of the blob and how blob is located and stuff like that. So yeah, but I think 80 was actually kind of good, more or less. 80 was, yeah, was all right for what it was doing. So, but if we take a look at the clock, so where is this thing? Can I maybe like put it in here and remove that stuff? So just these things. Nah, I guess that's fine. Right, so to be fair, I think yeah, I'm gonna call it a day. Right, so this is already pretty good end product, more or less. All right, so it's like it's already demoable, honestly. It's already kind of demoable. So I don't really know what else you can do in here. So I think that's this thing I'm gonna publish. So it's so cool, it could be adapted for new timer, a tea break. What do you think? Maybe, probably, I don't freaking know. But yeah, that's kind of cool. I'm still thinking, how would you? So notice this. Notice what? So there is a inline assembly directive for embedding files. Nah. Well, okay. Listen. We already won. We implemented a pretty cool thing without any cheats already. So let's actually continue. Let's actually continue with no cheat run. Okay, it's pretty cool that there's some ways to cheat in here, but I mean, we already won no cheat run. So that's pretty cool. That's pretty cool. And like, I'm really thinking, like, how can we even, like, so the formatting of the blob heavily depends on the formatting of the whole thing itself. So I don't think we can do much in here, honestly. I don't think we can do much in here. Glitchless 20%, yeah, glitchless 20%. Okay, so I guess that's it for today, right? So that's the end thing. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. All right, love you all. Mwah.